Okay. So that I need to mention for the Colombo students, in your Google Classroom, you only mention the names. So it is very difficult to put that assignment marks into the, according to, that means Colombo ATI send the mark sheet with the registration numbers. So that means it is very difficult to put the marks. හරිද? මට ඒක කියන්න අමතකුණා පැතුම්ටත්. පැතුම් ඉන්නවද?
ඔව් මැඩම්.
පැතුම් චුට්ටක් පුළුවන් නම් Google Classroom එකේ මේ හැමෝම දැන් කොලම්බෝවා ඉන්නවනේ මෙතන ඔයගොල්ලන්ගේ name වලට මේ registration number එක add කරන්න පුළුවන්ද? micro වල micro 3 එකේ නම දැන් ඔයගොල්ලන්ගේ මේ මොනවාද mark sheet එකේ තියෙන නමයි registration number එක.
එතකොට Google Class එකේ නම වෙනස් කරන්න කියලාද මැඩම් කියන්නේ?
ඔව්. මොකද දැන් ඔයගොල්ලන් ඉන්නේ එක නම් වලින්.
මේ අර මැඩම් මේ එක නම කියන්නේ අර ඊමේල් එකේ තියෙන නම තමයි මම හිතන්නේ මේ classroom එකට තියෙන්නේ. එතකොට වෙනස් කරන්න පුළුවන්.
edit කරන්න බැරිද?
මම පොඩ්ඩක් බලන්න මැඩම්.
කරන්න පුළුවන් චුට්ටක් බලන්නකෝ.
හරි.
මොකද මේ නැත්තම් මට මාක් සෙන්ටර් කරන එක හරිම ප්‍රශ්නයක් වෙලා දැන්. ඒ කියන්නේ දැන් registration number එකත් එක දැන් අරකෙත් තියෙන්නේ මේ හරියටම මට මෙයාද කියලා clarify කරගන්න බෑ. දැන් මේ mark sheet එකේ ඉන්නේ ඔයගොල්ලන්ගේ surname එක විතරයිනේ. තේරුණාද?
ඔව් මැඩම් මම පොඩ්ඩක් බලන්නයි.
ඒ හින්දා චුට්ටක් බලන්න registration number එක සම්පූර්ණ නෙමෙයි. number එකේ අන්තිම digit ටික මට add කරා නම් නමට ඇති. හරිද? මට ඒකයි වැදගත් වෙන්නේ. මේ එහෙම නැතුව හරි අමාරුයි මේ මොකද මම දැන් marks ටික මේව කල් ඉවරයි. ඒක මේ ඔයගොල්ලන්ට බලන්න පුළුවන් වේවි සම. ඒ කියන්නේ දැන් මෙතන නමනේ තියෙන්නේ ඔයගොල්ලන්ගේ ඊමේල් එක නෙවෙයිනේ. ඒ හින්දා පුළුවන් වෙයි චුට්ටක් බලන්නකෝ ඒක. ඔයගොල්ලන්ට තමයි එඩිට් කරන්න පුළුවන් වෙන්නේ. මට නෙමෙයි. චුට්ටක් පුළුවන් නම් ඒක එඩිට් කරන්න නැත්නම් මේ මම කොහොම හරි දාන්නම් දාලා හැමුණත් මොන හරි මේකක් ගැන මේක ඩිස්කස් කරන්නම්කෝ. හරි. Okay, so then we are starting that micro revision. එතකොට මම බැලුවේ 2018 paper එක ඩිස්කස් කරන්න 2018 and 19. Okay. හරිද? ඒක කමක් නැද්ද? ඊට පස්සේ අපි මේ කරපු lecture notes ටිකක් අපි මේවා කරමු. Okay. In the 2018 paper, normally that in the first question comes with that stored program concept. හරිද? එතකොට there that I am going to my slides. Okay, so there that you can see this is the normally that what is the microcontroller and the microprocessor that differences are mentioned in there, and normally the stored program concept comes from here. Okay, in the stored program concept, so that in the 2018 question they are asking explain the concept of stored program with first stored program in the computer. So normally we know that we discussed that what is the first stored program. It is the von Neumann architecture. What is the von Neumann architecture? It is the first stage of our micro lecture, von Neumann architecture. So that stored program concept you have to discuss. Okay, so this is the stored program concept. So there you know that here I mentioned that one. It is the von Neumann architecture. There you can see that von Neumann architecture. Von Neumann architecture is the first stored program concept, and there are the three major units are in the computer. In that von Neumann architecture means it has only three major units. So those things you have to explain. හරිද? එතකොට මෙතන කියන්නේ explain the concept of stored program with the first stored program in a computer. එතකොට first stored program එක තමයි von Neumann architecture එක. So that means you have to explain these things. There are three major units: memory, processor, and the I/O devices, I/O units. So in the memory, you have to explain something. And the processor also you need to explain. There are that fetch, decode, and executions are there. In the processor, normally we can divide it into two segments. It is the control unit and the ALU. All the arithmetic and logical operations are done through the ALU. And that controlling parts, all the control signals are sending through the control unit. Okay, so likewise, you have to mention those things. Okay, so if you can, it is better to draw this diagram. And so here you can easily mention that what is the von Neumann architecture. Von Neumann architecture is based on the stored program computer concept, where instruction data and the program data are stored in the same memory. The instruction data and the program data are stored in the same memory. That is the von Neumann architecture. That other one is which one? Von Neumann architecture and the Harvard architecture. So there it is that separate. That instruction data and the program data are not in the same memory, in the two separate locations. So here von Neumann architecture is, that is the major one. Instruction data and the program data are stored in the same memory. That is the major thing. So this is the architecture. This shows the all the components, von Neumann architecture, I/O devices and the processor and the memory. Okay, memory and the control unit, that memory units and the CPU. In the CPU, it consists ALU and the control unit. So likewise, this is the main architecture. In the 2019 paper also, they are in the first question, what is the von Neumann architecture model? And explain the 5 parts on the von Neumann architecture model. එතකොට එතෙන්දි කියලා කියන්නේ von Neumann architecture එක mention කරලා 5 parts mention කරන්න. හරිද? එතකොට ALU, control unit, memory and that I/O devices, and 5 parts වෙනකොට system buses also you can take. හරිද? System bus ටිකක් ගන්න පුළුවන්. Control unit, that memory, 1, 2, 3 arithmetic logic unit, that I/O devices, එතකොට එන්නේ 1 2 3 4යි. අනිත් පහට ගන්න system buses. Okay, 5 parts කිව්වොත් system buses you can take. හරිද? එතකොට ඒ වගේ question එකක් තමයි normally comes to as the first question, first part. ඊළඟට හරිද? එතකොට von Neumann එකේ අපි ওই ටික තමයි discuss කරේ. සමහර වෙලාවට Harvard architecture එක ඇහුවොත්, so there you can see here. Their data memory and the program memory are in the 2 separate locations, not in the same memory. Not as the same. So here data and the memory are in the same location. Here what happened? It is in the 2 separate locations. There you can see in the von Neumann, same memory holds data and instruction. A single set of address data buses between CPU and memory, single set. Harvard architecture, separate memories for data and instructions. From the diagram, you can see there, data and the program instructions are in the 2 separate memories. 2 set of address buses are there. The 2 memory locations, 2 separate address buses need to be allocated for the Harvard architecture. Difference mention it is easy, it is easy and you can gain more marks if you can sketch those diagrams. It is easy. Mention okay, any problems? Next there I mentioned that what is the system buses. Normally system buses means hardwired system. The wired or the lines for the communication between the microprocessor and the other components, peripherals. So there are normally 3 buses are there: address bus, data bus and the control bus. So you can remember this one. Diagram it is easy. So this one is the address bus, control bus and the data bus. Control bus is the bidirectional one. Control bus is bidirectional because CPU to and CPU to the bus and the bus to CPU. Okay. Another one, data bus to the CPU is bidirectional. To the memory also bidirectional. From the input only unidirectional to the data bus. Input එකට අපිට දෙන්න බෑනේ computer එකෙන් feed කරන්න බෑ. So input to the data output from the computer to the output. And other things, others you can see that control buses are, which one it is bidirectional. So here you can see that from CPU to send that address to the address bus and address to the memory location, that input also address to the input, and they are addressed to the output devices. Okay, so these directions also remember. So here address bus means it carries the address, which is a unique binary pattern. We know that address is the unique binary pattern used to identify a memory location or an input-output port. It is the unidirectional. Okay, address bus is unidirectional. Data bus means the data bus is used to transfer data between memory and the processor. And then the memory and the processor data transfer කරන්නේ මොකකින්ද? Data bus එකෙන් it is bidirectional. The data buses are bidirectional. Here you can see CPU and the memory. Inside data buses are bidirectional. මේ IO කොහොමත් මොකද වෙන්නේ? Input එකෙන් computer එකෙන් input එකට දෙන්න බැහැනේ නේද? Input එකෙන් computer එකට දෙන්න. So that means it is this direction. Output also that direction. හරිද? නැත්නම් අනිත් data buses මොකද වෙන්නේ? Bidirectional. Control bus. The control bus carry control currents, which consist of signals for selection of memory or IO devices with the given address. The direction of data transfer and synchronization data. Control bus එක ගොඩාක් කරන්නේ මොකද්ද? Synchronization of data transfer. Okay? Synchronizing signals, timing signals, control signals sent to the control bus. Okay, so those are the major three buses available in the computer system buses. හරිද? එතකොට system buses ගැන what you have to mention those things. Okay. Another thing, this you can go through. In the 2018 they are asking what is the basic concept of Flines classification. Explain 4 different types of Flines classification with an appropriate diagram. Okay, Flines classification එකෙන් අහන්න පුළුවන්. So they are in the Flines classification. I think they are this one. Okay, so here Flines taxonomy. Flines taxonomy means you have to remember this thing. මෙන්න මේක තමයි ඕනේ. What is the basic concept of Flines classification? So normally that Flines classification means this one. That normally that in instructions and data. Okay, instructions and data process according to some in some architecture. So that is we are calling the Flines classification. Okay, so there you can see that there are 4 types: SISD, SIMD, MISD, and MIMD. Okay, single instruction, single data stream, single instruction, multiple data stream, multiple instruction, single data stream, multiple instruction, multiple data stream. Okay, so likewise that you can see that this type of thing. Here you can see what happened there. That in this diagram, it is better to remember that diagram. This is the instruction set mentioned there in this side. Here is the data set mentioned. Single instruction and the multiple instructions are there. Okay, and they are single data. Single data and the multiple data stream. Okay, so likewise you can mention those things. And I mentioned all that explanations are here. Okay, all the explanations are mentioned there. Here you can see that if you want to, that here mention explain 4 different types of Flines classification with an appropriate diagrams. So the appropriate diagrams you have to mention that are 4 different types. 4 different types when you are mentioning with the appropriate diagram, it is this one. Okay, here you can see SISD. That means single instruction, single data. So what a single instruction pool is there. Only one single is feeding into the processor. Only one data is processing at that time. And the single processor, single instruction, and that it is a uniprocessor we are calling. It is this type of program can be run there. Okay, load A, load B, C equals A plus B, store C. Likewise, very small program you can write. And that's what a instruction, a data set. Okay, not the several instructions can be performed because it is uniprocessor. Okay, it is the uniprocessor. Here, conventional single processor, one human computer are classified with SISD. Okay, so these diagrams are very important. So, diagrams are important. Here, single instruction, multiple data set. Okay, there you can see single instruction. Ekam instruction එක තියෙන්නේ. Ekam instruction එක feed වෙනවා several processors වලට, but multiple data set. Data are different. Okay, several data are there. Only one single program is running there. And it is like that. මේ බලන්න මේ වගේ program එකක්. එතකොට previous instruction load A, load B, C equals A into B. Okay, මේ වගේ චූටි program එකක් you can mention there. There also what happened? Load A, load B, C equals A into B. In there also which one? Nth one also same. P1, P2, Pn processors. But what happened? Data are different. Say not the same data. This is first one, data one. Okay, whatever the one first set. This is second set, that is the nth set or the third set. And the data are multiple data are accessing for the single instruction set. That is SIMD. ඊට පස්සේ here MISD, multiple instruction, single data stream. Single data में එකම data line එකයි තියෙන්නේ. Multiple instructions. Okay, that means multiple processors are there, but same data is feeding to first processor and the second processor. But that instruction streams are different. එතකොට මෙතන බලන්න that instruction streams are different. Load A, load A, load A. Okay, that here you can see C1 equals A into 1, C2 equals A into 2. Okay, Cn equals A into N. හරිද? එතකොට මෙතන මේ 1 2 3 n 3 n likewise. That means what happened? That instructions are different. හරිද? මේවා සමාන වුණාට instructions මොකද වෙලා තියෙන්නේ? It is different. But we are feeding the same data. මේ A1 data එක තමයි හැමතැනටම feed කරන්නේ. Here you can see same data is feeding into the each and every locations. හරිද? That is MISD. Multiple instruction, single data. Okay. This is this type of thing. Normally we are not using this type of, okay, rarely use these ones. Here is Z equals sin x cos x plus tan x. So sin x, cos x, tan x. These are three different instructions. Okay, instruction pools are several different, but x value data set is same. Okay, we have to calculate sin x, we have to calculate cos x and the tan x. Three different instructions are there, but for the same data set. Okay, so this one is we are calling MISD. A few machines are built, but none of them are available commercially. Okay, commercially not available those type of machines. Here multiple instruction, multiple data set, MIMD. So there you can see multiple instructions and multiple data sets. Okay, so here you can see instructions, several instructions are there and data set also there. Okay, multiple processors are functioning. MIMD model, it is the networking. Okay, exchange information through interconnected network. Is message passing system. Okay, normally in the network computers, we are using the multiple instruction, multiple data set. Here you can see this type of thing. හරිද? Instruction set එකත් මොකද වෙලා තියෙන්නේ? Different. Data also different. හරිද? It is this type of thing. Normally, in our day-to-day life, that in the present day-to-day life, networking computers are followed that MIMD programming. MIMT architecture is followed there. So this is the basic Flines architecture, Flines classification. Okay, 4 types. When you are explaining the 4 different types, you have to mention those 4. Better to explain with that example. Okay, so that means at that time you can easily gain the marks. And here I mention other thing also, shared memory and that distributed memory. Okay, so there you can see it is the shared memory. Shared memory, that memory is sharing. Here you can see the memory locations and there is the processors. And මේ processor එකට කෙලින්ම memory එකක් allocate වෙලා නැහැ. Okay, that processor can access this memory or that memory. It is the shared network. Shared interconnection is there. But here what happened? It is the, which one? It is the distributed memory. That memory is distributed among each and every processor. So මේ processor එකට මේ memory එක විතරයි තියෙන්නේ. Okay, it cannot access the other memory. So that means it is the that distributed memory. This one is the shared memory. This is the distributed memory. Okay, so these things you can go. And in and in 2018, our third part is the briefly describe the features of the CISC CPU and the CISC CPU. I think that part is not in there. Okay, so in the later I will discuss that one. මම ඒක මේ පස්සේ discuss කරන්නම් ඒ ඒකයි. ඊට පස්සේ ගොඩක් වෙලාවට එන එකක් තමයි this one. Okay, in the second question they are asking, draw the diagram of computer level hierarchy in actual multi-level viewpoint of the computer and briefly explain each level of it. හරිද? එතකොට this is the multi-level viewpoint. හරිද? So you have to draw this one. Okay, normally in the normal computer level hierarchy there are 7 layers. Okay, there are 7 layers of architecture. That digital logic is the first 0th layer, first one control, and the machine layer, system software, assembly language, high level language, and the user interaction. Okay, so those are the that available 7 layer actual multi-level viewpoint of the computer. So normally in the most questions they are asking. In the 2019 question also, in the 2019 second part, they asked the draw the diagram of computer level hierarchy in actual multi-level viewpoint of the computer and briefly describe each of you. එතකොට මෙන්න මේක තමයි අඳින්න තියෙන්නේ. That is the computer level hierarchy. හරිද? computer level hierarchy එක ඇඳලා there are 7 layers. You have to mention the 7 layers. හරිද? ඇඳලා what happened? Each and every layer you need to mention. හරිද? එතකොට මෙන්න මේ ටික මතක තියාගන්න. That 0th layer is the digital layer. 0th layer is the digital layer. It is the circuit. Circuit level. It is the circuit level. And that first one is the control layer, control level. Okay. So that microcode, the hardwired one. Next one is the machine level. Instruction set architecture is there in the machine level. Next one, system software, operating systems. And the library codes are there. Assembly language, assembly codes, high level language, that means C, C++, whatever the high level language is following through there. And the user means that interaction, interface between the user. User interface level is this one. So likewise, these 7 layers you have to mention. Either. So here I mentioned that all the, what are the that available features and what is this one. Either here digital logic level. That means this level is where we find the digital circuits. All the chips and the digital circuit is consist in this level, motherboard. Digital circuit consists the gates and the wires. These components implement the mathematical logic for the other on and off thing. In the control level, control unit decodes and executes instruction and moves data through the system. Control unit can be programmed or hardwired one. Okay, so likewise, these things you can explain each and every level. Machine level means instruction set architecture level. It consists the instructions that are particular to the architecture of the machine. So likewise, you have to mention the machine level. And there are systems of tier level. It is, we have that operating systems. Okay, and the library files are there. Compilers, interpreters, linkers, those things are included in there. Systems of tier level. Assembly language level means assembly language. That production is there. Okay, so that means assembly, that lowest human readable level, that mostly that it directly linked with the machine language. And this is the high level language, more user friendly level is this one. Easy to, that is the human readable level. That level consists the which one? That applications, all the applications with the high level language. That means C, C++, Java, likewise. And other, this one is the program execution and the user interface level. That is the user interface level. Okay, so likewise, you have to mention every 7 days, you have to draw that one first. Okay, this one, may level stick on it. And then each and every level you have to mention. Okay, so this is that question normally. Multi-level viewpoint of the machine. In the 2018, in the second question, second part, write 5 factors to measure performance of a computer. Performance of the computer. Make it okay, so they are that in the 2019 one, they are asking define the CPU execution time and write 5 factors affecting on CPU performance. එකම වගේ තමයි එකම questions වගේ තමයි normally අහන්නේ. හරිද? ඒ හින්දා papers 3-4ක් කරලා යන්න. It is that you can gain the marks. ඒතකොට CPU performance calculations අහන්නේ. හරිද? ඒකට CPU performance calculations I think here. Okay, I think there performance metrics in the third lecture, I think. We are seeing that here factors of performance. හරිද මොනවද computer performance වලට බලපාන factors. Write 5 factors to measure performance of the computer. හරිද මේ මයික්‍රෝ ලොකුවට බය වෙන්න දෙයක් නැහැ. හරිද මයික්‍රෝ වලින් මොනවත් අපිට කරකවකව අහන්න බෑ. Okay, so because that when we are thinking about electronics and that machine, ඒ වගේ දේවල් වල මොනවද අපිට questions create කරන්න පුළුවන්. Okay, that because we are tackle with the mathematical calculations there. So that means we can create that normally, that questions are creatable one. But in the micro, it is totally theoretical one. Very small set of mathematical that calculations are there. ගොඩක් වෙලාවට you have to answer the theory parts. හරිද? ඒක තමයි ඔයගොල්ලන්ට ටිකක් අමාරු නේද? ගණන් හදන්න නම් ගණන් දෙක හදුවම you can easily remember those.
මේක හිවිසාන් නේද? ඈ?
Okay. ඉතින් ඒ හින්දා හැමතිස්සෙම බලන්න මේ කරපු ටික repeat කරන්න. හරිද? කියපු ටික කරපු ටික ආයි කීප සැරයක් කරන්න with මේ question papers එක්ක. Here you can see factors of performance. There are the factors. Okay, here I mentioned 7 factors. More factors also there. Here response time. Response time should be short. Short response time for a given piece of work. Throughput. Throughput එක මොකද වෙන්න ඕනේ? high. නේද? Throughput is high. Low utilization of computing resources. Computer resources utilization should be low. High availability of the computer system. Fast data compression and decompression. Compression and decompression. Data compression and decompression should be fast. Bandwidth. High bandwidth should be there. Data transmission time should be short. Low data transmission time. So those are the major factors for the computer CPU performance. Okay, so each and everything you can explain. Write 5 factors to measure the performance of the computer. Okay. ඊට පස්සේ 2018 1 එක තව අහනවා define the followings define කරන්න කියලා. Response time and throughput. එතකොට I think මම ඒ ටිකම කියලා දීලා ඇත්තේ. Response time and the throughput. හරිද? Response time is how long it takes to do a task. That is the response time. Throughput means total work done per unit time. Total work done per unit time. To unit time එකක් ඇතුළත කරන total work done එක. That is the throughput. Response time එකක් කියලා කියන්නේ task එකක් complete කරන්න කොච්චර කාලයක් යනවද. That is the response time. Okay, response time and the throughput. Okay. Another one is the CPU time. So CPU time also mentioned there. CPU period, that is the duration of the clock cycle. Okay, duration of the clock cycle. So here that within one, this is the clock period. So that clock period gives which one? Data transferring for the computation speed. Okay, so that is the CPU type. That execution time also the CPU time. It is execution time of a given task is defined as the time spent by the system to execute that task. Okay, the clock cycle එකකදී අපි මොකද කරන්නේ? Clock cycle instead of reporting execution time in එක. ඒ කියන්නේ එක clock cycle එකකදී අපි එක data එක execution එකක් perform කරනවා. Okay, that is the CPU time. So the execution time or the CPU time can be divided into two categories. මොනවාද? Two parts, user time and the system time. So the user time is spent running the application program itself. System time is application calls operating system code. That calling codes, that time we are calling the system time. That running the application, that called the user time. The user application program එක හදාන්න, it is the user time. Both include to the which one? CPU time. Okay, so here we can calculate the performance. හරිද? සමහර දවසට අපිට performance calculate කරන්න දෙනවා. CPU time equals instructions into cycles per instruction into seconds per cycle. හරිද? Cycles per instruction. Divide by clock rate into instruction is the CPU time. Okay, the performance කියන්නේ මොකද්ද? 1 over CPU time. 1 over CPU time gives the performance. CPU time එක වැඩි නම් it shows the less performance. CPU time එක අඩු නම් it shows the higher performance. Okay, so that means it is the reciprocal of that one. So there are some other calculations also. That CPU time, it is this one, cycles per instructions. හරිද? Cycles per එක instruction එකට කොච්චර cycles ද? Divide by cycles, seconds per cycle. Cycle එකේ, that means clock rate. Okay, average CPI divide by clock rate into the instructions. That is the CPU type. So we are discussed there that is static instruction count and the dynamic instruction count. Those two also we discussed. Static instruction count means මොකද්ද? How many lines in the code. Dynamic instruction count is actually how the program is executed. Actually how many lines executed by the program when program running. Okay. So here in this example, I'll show you that I'll show you how that static and the dynamic instruction counts are behave. Here you can see they are in that above the program there are 250 instructions are there. After that therefore I equals 1 to 100 do. There are 20 instructions in between that one. So the for loop is there, j equals 1 to 100 do, and 40 instructions are there likewise. Okay. So there you can see that static instruction count is 326. මෙතන 250ක් තියෙනවා, මෙතන 1යි, මෙතන 21ක් එනවා, here 41, මෙතන එනවා කොච්චර 2යි, 11ක් එනවා, likewise. 326 static instruction count. That means number of instructions, number of lines in the instruction. Okay, number of lines in the program. That is the static instruction count. But in the dynamic instruction count means which one? Actually, how many instructions are performing within that computer? එතකොට මොකද වෙන්නේ මෙතන for I equals 1 to 100 do. එතකොට එකේ ඉඳලා කීය වෙනකන්ද 100 වෙනකන් මෙතන මොකද වෙන්නේ for loop එකක් execute වෙනවා. හරිද? So that means there are several instruction. මේ අන්තිම එක ගන්නකො මේකනේ පොඩිම for loop එක නේද? For k equals 1 to 100 do 110 instructions. හරිද? එතකොට මෙයාගේ for k equals 1 10 instructions. that මොහරි instructions 10ක් calculate කරනවා n4. එතන එක k equals 1 instruction එකට කොච්චර තියෙනවද මෙතන 12. 12 instructions are there. ඒ වගේ කීයක් perform වෙන්නද 100ක් යනවා. k equals 1 to 100. එහෙනම් කොච්චර instructions ද? 12 into 100. That means 1200 instructions in all. හරිද? 1200 instruction in all. එතන මේ for loop එකට ඒ 1200 plus other ටික. නේද? මෙතන for එක එකයි, end of එකේ දෙකයි. මෙතන 40 instructions are there. මෙතන මේ loop එක මේ කොටු ඇතුළට එනවා කොච්චරද? That this number of instructions. ඇයි? 100 iterations කරන්නත් ඕනේ. j equals 1 to 100. එතන මේ තියෙන ගාන මොකද වෙන්න ඕනේ? cn වැඩි වෙන්න ඕනේ. Okay? So likewise, when we are calculating the dynamic instruction count, it is that somewhat larger value. Okay, actual program values need to be considered there. හරි නේද එතකොට මේ දෙක. ඊට පස්සේ there are some calculations are here that some examples I mentioned there. මේ තියෙන CPU time එක කොහොමද calculate කරන්නේ? Computer 2 GHz plus 10 second CPU time. හරිද? ඒතර clock rate එක. How we can calculate the clock rate? Clock rate. එහෙනම් clock cycles divided by the CPU time. Clock rate of the B. Here design a computer B for 6 seconds CPU time and can have faster clock but causes 1.2 A clock cycles. A වල වගේ 1.2 වෙන්න ඕනේ clock cycle එක. හරිද? A වගේ 1.2 clock cycle should be there. 6 seconds. CPU time is the 6. එතකොට CPU time is 6. Clock cycles මොකද වෙන්නේ? මෙතන A වල clock cycles අපි දන්නවා. නේද? A වල clock cycles දන්නවා. So that means we have to multiply that clock cycles with the 1.2. 1.2 into this one. 1.2 into which one? 2 gigahertz. 1.2 into 2 gigahertz. So likewise, you have to calculate those things. I did these examples also. Define the following. Question paper ke response time and the throughput hari CPU time we discussed and MIPS millions of instructions per second. හරිනේ එක සෙකන්ඩ් එකකට millions of instructions are there. මේ ටික බලා ගන්න. එතකොට here you can see MIPS. Okay. එතකොට million instructions per second. එතකොට මේ මොනවද එක සෙකන්ඩ් එකකට million instructions perform වෙනවා. ඒ හින්දා ඒකට අපිට දැන් අර කියන්න බෑ ඒක ලොකු වැලියු එකක්. ඒ හින්දා අපි categorize කරනවා. How we can categorize dividing by 10 to the power 6. හරිද? instruction count divide by execution time divide by 10 to the power 6. 10 to the power 6 groups කොච්චරද තියෙන්නේ කියලා කියන්නේ. Okay, divide by 10 to the power 6 millions instructions per second. Millions instructions කොච්චර තියෙනවද? 10 6 group කොච්චර තියෙනවද කියලා තමයි millions instructions per second වලින් කියන්නේ. Okay, MIPS. The same thing. අනේ මේක තමයි 10 6කින් බෙදෙන්න ඕන. ඊළඟ අනිත් එක තමයි මේකේ අහලා තියෙන millions of floating point instructions per second, that one. MF LOPS. හරිද? ඒකෙත් ඔහොමමයි. එතන මොකද්ද වෙන්නේ? Millions of floating point operations. Millions of floating point operations are there. Okay. That 10 to the power 6 divided by. Refer to the total number of floating point operations executed in millions per second. तर ගොඩක් වෙලාවෙදී ඔය වගේ පොඩි ඒවා explain කරන්න කියලා අහනවා. Okay. So these things you can go through. ඊට පස්සේ in the 2018 one, they are asking that okay, so after that they are asking some questions, some calculations need to be performed. Consider an implementation of MIPS ISA with 500 megahertz clock and has following characteristics. That each ALU instruction takes 3 clock cycles, each branch instructions take 2 clock cycles, each switch instruction takes 4 clock cycles. Execution of one program has following executes. Following ever 200 million ALU instructions, 55 million branch instructions, 25 million switch instructions. Find CPI and CPU time assuming CPU execution is sequential. It is in the sequential manner. We have to okay, so there that you have to calculate that one. First one is the which one? CPI. Okay, clock per instructions. How we can calculate that one? Clock per instructions. Clock cycles for a program divided by instructions count. That we discuss. I will show you there. CPI, you have to calculate this one. Okay, CPI. That CPI equals which one? It is CPU time divided by instruction count. Okay, here you can see CPU time equals instruction into CPI. Okay. So that means CPU time divided by instructions gives the CPI. එතකොට CPU time එක හොයාගන්න. What is the CPU time? නේද? CPU time you have to find out. Total instruction count. How we can find out the CPU time? කොහොමද CPU time එක හොයන්නේ? 200 million ALU instructions. Okay, 200 million ALU instructions. Each ALU instruction takes 3 clock cycles. එක ALU instruction හැකට කොච්චර යනවද? 3 clock cycles are included. So there are 200 million ALU instructions means 200 into 3 plus 55 million branch instructions. But each branch instruction takes 2 clock cycles. 55 into 2 plus 25 million switch instructions. Each switch instruction takes 4 clock cycles. So 4 into 25. That is the which one? That is the total clock cycles. Cycles, that's CPU time. Clock cycles for a program. That is the CPU time. Clock cycles for a program. Divide by instruction count. What is the instruction count? 200 plus 55 plus 25. හරිනේ. ඉතින් අර තියෙන ඒවම easily calculate කරන්න පොඩ්ඩක් තේරුම් අරන්. Okay, so that is why we are getting the CPI. After that, they need to calculate CPU time. Okay, CPU time. CPU means which one? Instruction count into CPI over clock rate. CPU time equals instruction count into CPI divided by clock rate. The instruction count එක අපි දන්නවා කීයද? 200 plus 55 plus 25. මේවයි millions instructions වලින්ම යන්න. හරිද? එතකොට ඒක into කීයද? CPI එක අපි හොයාගත්තා. Okay, cycles per instructions අපි හොයාගත්තා. There's a divide by clock rate. What is the clock rate? MIPS clock rate එක කීයද? 500 megahertz clock. The clock rate එක 500. 500 megahertz means 500 into 10 to the power 6. So likewise, you can calculate the CPU time. Any questions? Easily you can do the calculations. ඔය වගේම තමයි 2019 paper එකේ තියෙන්නේ. Okay, most of them are same.
Madam,
yes,
madam, clock cycle එක අර CPI එකට සමාන කරපු චුට්ටක් අය කියනවා.
කොතනද කියවෙන එක CPI ද?
ඔව්.
CPI means which one? Cycles per instruction. Okay, එක instructions එකට කොච්චර cycles යනවද කියන එක. cycles per instruction. එතකොට එක cycle එකකට යන instruction ගාන මොකද කරන්න ඕනේ? අපි total cycles වලට යන instruction ගාන divide by number of instructions තමයි යන්නේ මොකද්ද? එක cycle එකකට යන instructions ගාන වෙන්නේ. හරිද? cycles per instruction. එක instruction එකකට යන cycles. හරිද? cycles per instruction. එතකොට එක instruction එකකට යන cycles ගාන ඕනේ. එහෙනම් total යන cycles ගාන divide by number of instructions. තේරුණාද? CPI means cycles per instruction. හරිද? එතකොට cycles per instruction. එක instruction එකකට යන cycles ගානනේ ඕනේ. හරිද? එහෙනම් මොකද කරන්න ඕනේ අපි? total program එකට යන cycles ගාන හොයලා total number of instructions වලින් බෙදුවහම මොකක්ද එන්නේ? එක instruction එකකට යන cycles ගාන එනවා. හරිද? clock cycles for a program divide by number of instruction. නැත්නම් instruction count. හරිද?
madam, එතකොට මේ clock cycle කියලා ගන්න අපි මුළු total
clock cycles for a program නේ. එතකොට total program එකට යන clock cycles බලන්න ඕනේ. total program එකේ අපිට කියලා තියෙන්නේ කොහොමද මේකේ? 200 million ALU instructions, 55 million branch instructions, 25 million switch instructions. ඔය ටික තමයි අපේ program එක. තේරුණාද? paper එක තියෙනවද ළඟ?
ඔව් madam.
හරි. එතකොට ALU instruction එකක් එක clock cycle එකකින් complete වෙන්නේ නැහැ. තේරුණාද? ALU instruction එක මේක දීලා තියෙනවා. ALU instruction take 3 clock cycles. ALU එක instruction එකකට clock cycles කීයක් යනවද? 3ක් include වෙනවා. හරිද? එතකොට මේ program එකේ තියෙනවා 200 million ALU instructions. එතකොට කොච්චර යනවද total ALU instructions වලට? clock cycles කොච්චර යනවද? 200 into 3. හරිද?
හරි madam.
හරි. 55 million branch instructions. මේ program එකේ branch instructions branches තියෙනවා කොච්චරද? 55 millions තියෙනවා. එතකොට එක branch instruction එකක් එක clock cycle එකකින් complete වෙන්නේ නැහැ. ඒකට යනවා කොච්චරද? branch instruction takes 2 clock cycles. clock cycle දෙකක් යනවා. එහෙනම් 55කට කොච්චර යනවද? 55 into 2. 25 million switch instructions. switching when instructions තියෙනවා 25 million. එක switching instruction එකකට takes 4 clock cycles. එතකොට 25ට යනවා 25 into 4. තේරුණාද? එතකොට ඔන්න ඔච්චර clock cycles ගානක් යනවා මොකටද මේ total program එකට. හරිද? එතකොට අපෙන් අහන්නේ CPI clock cycles per instruction. එක instruction එකකට කොච්චර clock cycles යනවද? This is normally asking the average value. හරිද? අපිට නැතුව කියන්න බෑ. එක instruction එකකට කොච්චර clock cycles යනවද? මොකද ALU instruction එකකට 3 clock cycles. We are finding out the average CPI. හරිද? We are finding the average value. එතකොට total number of clock cycles for a program එනවා කොච්චරද? 200 into 3 plus 55 into 2 plus 25 into 4. Total number of instructions වලින් එක බෙදෙන්න ඕනේ. Total clock cycles තමයි මේ ආවේ. ඒක instructions count එකෙන් බෙදුවහම මොකද එන්නේ අපිට? Cycles per instruction. CPI. Instruction count එක කීයද? 200 plus 55 plus 25. හරිද? තේරුණාද?
හරි madam, thank you.
හරි. ඊට පස්සේ හොයන්න තියෙන CPU time එක. CPU time already which one? Instruction count into which one? CPI divide by clock rate. හරිද? Instruction count එක අපි දන්නවා 200 plus 55 plus 25. ඊළඟට into CPI. CPI already we calculated in the first part. Divide by clock rate. Clock rate is given as 500 megahertz. So 500 into 10 to the power 6. Is it okay? Any questions? Never මතක තියාගන්න එපා. CPI means which one? Clock, that's cycles per instruction. Likewise. එක instruction එකකට clock cycles. ඒක අහලා තියන්නේ ඇයි? ALU instruction එකට 3 clock cycles යනවා. Branch එකකට 2 යනවා. එහෙනම් average value we have to find out. So average වෙනවා total instructions වලට යන clock ගාන බෙදනවා number of instructions වල. එතකොට එනවා එකක ගාන. That is the CPI. හරි. ඊට පස්සේ in 2018 next question is the pipeline. හරිද? එතකොට pipeline question එකක් අනිවාර්යෙන් එනවා. Okay. I'll go through that one. Fourth lecture is the pipeline. හරිද? So there with the question we are going through, ne? It is easy. With the help of a suitable diagram, explain the characteristic of non-pipeline CPU and the pipeline CPU. මේ ගත්ත ගමම තියෙනවා. හරිද? So in the non-pipeline CPU means total problem feed as a that into the CPU as a whole thing. Okay, as a whole. But in the pipeline means it is divided into several segments and feed into the CPU. හරිද? එතකොට ඕක තමයි suitable diagrams වලින් explain කරන්න කියලා තියෙන්නේ. හරිද? එතකොට suitable diagram explain කරනකොට ඕක. මේ total problem එක feed කරනවා CPU එකට likewise. මෙතන මොකක්ද වෙන්නේ? problem එක divide කරලා ඒක feed කරනවා CPU වලට. Okay? So it is like a parallel processing. අපි මේවා discuss කරා. Okay? හරිද? එතකොට මෙතෙන්දී එක වැඩකට යන time එක නෙවෙයි අඩු වෙන්නේ. මොකද්ද? that total work done එකට යන time එක තමයි අඩු වෙන්නේ. හරිද? කොහොමත් එක වැඩකට යන time එක already same. But when we are considering the total, that 4 loads when we are considering, that total time is reducing. හරිද? මතකයි නේද අපි මේකට එක වැඩකට දැන් මේ එක රෙදි ටික සෝදන්න යනවා කොච්චර වෙලාවක්ද? It takes 120, that means 2 hours. Okay, 2 hours are taken to that wash and clean that whatever the after folding instead. Okay, complete one task, it takes how much of time? 2 hours. For a 4 task, 8 hours for the 4 load. But when we are doing with that pipelining, applying the concept of that one, it makes 3.5 hours to complete that 4 loads. Harida? So that means throughput is increasing. Harida? දැන් total work එකට යන කාලය තමයි අපිට අඩු වෙන්නේ. නැතුව individual task එකකට යන කාලය නෙමෙයි. For individual task it takes same time. But when we are considering the whole complete load, complete task, it takes low time. Okay, so that is the major importance of the pipeline. හරිද? මේ තියෙන latency එකට help කරන්නේ නැහැ. හරිද? Latency means the single task. Okay, what is the time, execution time for a single task? We are calling the latency. Okay, pipelining does not help to latency, but it helps to throughput for the entire work. Okay, for the entire work, throughput එකට තමයි help කරන්නේ. Okay, so this is the normally here you can see that whole set we are feeding for the non-pipelining. In the pipelining set, but we are dividing that question problem into several stages and feed into the as a that in the part of that one. හරිද? එතකොට ඕක තමයි explain කරන්න ඕනේ. So when that feeding there some මේක තියෙනවා. Pipeline
Excuse me,
registers are there, some overload. Oh,
ස්ක්‍රීන් ෂෙයා කරන්න මැඩම්.
screen share කරලා නැද්ද? Oh, very sorry. හරි. ඒ වෙලාවට චුට්ටක් මට මතක් කරන්න. මොකද මම දැන් කීපයක් කරනවානේ. මම ඉස්සෙල්ලා කිව්වේ මේක. හරිද? මේ laundry එකේ කතන්දරේ that when we are considering one load when we are considering it takes 2 hours. හරිද? එතකොට 4 loads ගත්තොත් කොච්චර hours? 8 hours normally taken for a non-pipelining case. When we do as a pipelining, it takes which one? 3.5 hours. We are dividing that in the task into the several segments and we feed like that. But we are not minimizing or controlling that time taken for a one task. Make a task time එක අපිට බෑ අඩු කරන්න. හරිද? But when we are considering the whole load, whole set, we can reduce the time. Is it okay? That is the importance of the pipeline. So here you can see that pipeline does not help to latency. Latency කියලා කියන්නේ මොකද? Execution time for one single task. So execution time for a single task we cannot reduce. It normally takes that time. But when we are considering the throughput, it helps to the throughput of entire workflow. Throughput එක ගත්තොත් ඒක මොකද වෙන්නේ? ඒක we help to do the throughput. Okay, so that is the normal advantage of the pipelining. එතකොට මෙතන මේ වගේ එකක් තමයි ඔයගලන්ට explain කරන්න ඕනේ. This is the non-pipelining case. Okay, this one is the pipelining thing. Non-pipelining means whole set of program feed into as the one unit. Here in the pipelining one, what happened? We are dividing program into several segments and feed into the execution. Okay, as a unit. So here one disadvantage is there what happened? A pipeline register, some that overhead is there. Pipeline registers are there, some overhead it is appearing into the pipeline. That when we are considering the throughput, it doesn't matter. Okay, so you can go through these things. After that, yes.
Madam, මේකේ මේ notes ටික අපිට කොහෙන්ද madam ගන්න පුළුවන්? අපි අර එක දිගට training එක මේ ටික හම්බ වෙච්ච නැති නිසා මේ notes ටික කොහෙද තියෙන්නේ? LMS එකේද?
මම නම් දන්නේ නැහැ. දැන් LMS එක කොහොම මම දන්නේ නැහැ. මොකද මයික්‍රෝ මේ semesters වල නැති හින්දා I don't know. මට ඒක දන්නේ නැහැ. goal වල ළමයි ඒ students ළඟ නම් ඇති සමහර විට. මොකද කරනකොට මම මේ ටික දැම්මා අප්ලෝඩ් කරා. මට දැන් මයික්‍රෝ වලට අප්ලෝඩ් කරන්න බෑ මම හිතන්නේ. මොකද මයික්‍රෝ එක ඕගොල්ලන් ලින්ක් කළා තියුණාට අපි වයින් කරලා තියෙන්නේ වගේ.
ඒකේ මැඩම් ඒකට අප්ලෝඩ් කරේ ඒක න නෝට්ස් වගේක් තියෙනවා.
එහෙනම් හරි.
හරි මැඩම්.
ඒක තමයි. මයික්‍රෝ මේ අප්ලෝඩ් කරේ එහෙම තමයි.
හරි මැඩම්. thank you.
හරි. notes වල මගේ හැම note එකේම තියෙන syllabus එකේ තියෙන content එක all the stuffs are mentioned. හරිද? ඉතින් ඒ හින්දා ඒ ටික ඔයගලන්ට බලන්න පුළුවන් නම් ඒක ගොඩක් වෙලාවට මේ හැම එකම තියෙනවා. හරි. ඊට පස්සේ ඊළඟ question එක බලමු අපි. ඇත්තටම question paper එකක් discuss කරනවා කියලා කියන්නේ ආයි මම අර මුලුවම මේවා ටික කරනවා වගේ වැඩක් නෙක. හරිද? සේරම මේ presentations ටික නැවත ඩිස්කස් වෙනවා. හරි. එතකොට මෙතන තියෙනවා list the important factors of the pipeline conflicts. මම ඊට කලින් මේක චුට්ටක් කියන්න. conflicts වලට අපි පස්සේ යමු. මෙතන ඊළඟ question එකේ තියෙනවා third question එකේ third part එක. Draw the block diagram for 4-stage pipeline by illustrating functions of each block. Draw space-time diagram for above 4-stage pipeline. ඉතින් ඕකක් අනිවාර්යෙන් දෙනවා. හරිද? Normally we discuss the 2-stage pipeline. මේක තමයි 2-stage line pipeline. Okay? This one is the 2-stage. එතකොට අපි තියෙන instructions අපි කොහොමද බෙදලා තියෙන්නේ? Fetch and execution. වලට විතරයි. For the 2-stage pipeline. හරිද? 2-stage pipeline එකක් අඳින්න කිව්වොත් මේක අඳින්න වෙන්නේ. හරිද? Timing diagram එක means this one. මෙන්න මේක තමයි timing diagram එක. Timing diagram for instruction pipeline operation. This is for the 6-stage pipeline. Okay? මෙන්න මේ වගේ එකක් තමයි ඔයගොල්ලන් timing diagram එකට අඳින්න ඕනේ. 2-stage pipeline නම් මෙතන 1 2 3 4 හැම යනවා. ඒතර 1 2 වලින් එක instruction එකක් fill වෙනවා. ඒ instruction එකට තියෙන fetch and decode විතරයි. fetch and execution විතරයි. හරිද? එතකොට fetch instruction, execution instruction විතරයි. ඒ දෙක වෙනකොට ඊළඟ එක පටන් ගන්නවා likewise. You have to draw. හරිද? එතකොට මෙතන තියෙන 6-stage pipeline. Okay? එතකොට මෙතන මේ බලන්නකෝ. එතකොට මේ තියෙන instruction pipeline එකක්, මේ තියෙන 6-stage එකකට තියෙන coding එකක්. හරිද? 6-stage coding එකක්. Fetch instruction, decode instruction, calculate operand, fetch operand, execution instruction and write instruction. Okay? එතන මේ තියෙන දෙකකට fetch and execution. ඊළඟට මම mention කළා ඇති this one is the 4-stage pipeline. 4-stage එකට මොකද? Instruction fetch, instruction decode, execute, write back. Okay? Fetch, decode, execution and write back. These are the 4-stage pipeline. Okay? මේ තියෙන 5-stage එක. හරිද? 2 3 4 5 6. ඕක තමයි normally අපේ structure එක. හරිද? This is the 5-stage pipeline. 5-stage එකේ මොකද්ද? Fetch, decode, execute, memory access and the write back. Here you can see instruction fetch, instruction decode, execution, that memory access and the write back. These are the 5-stage pipeline. එක instruction එකක් 5 stages වලට divide කරනවා. මේ this one is the non-pipeline. මේ සම්පූර්ණ instruction එක ඉවරනහම තමයි දෙවෙනි instruction එකේ පටන් ගන්න. Likewise, this is non-pipeline. This one is using the pipeline process. Instruction fetch එක ඉවරනහම එතන එයාගේ තියෙන මේ process එක empty. ඒ හින්දා second instruction එකේ ඒක ඒ ටික process වෙන්න ගන්න පුළුවන් ඒ process එක. Okay, so likewise, this is the pipelining thing. Okay. So here it mentioned only you have to draw the 4-stage pipeline and the space-time program. Space-time diagram you have to draw. Space-time diagram එක කියලා කියන්නේ මේක timing diagram. So 4-stage නම් 1 2 3 4 වලින් පළවෙනි හතරෙන් එක instruction එකක් finish වෙන්න ඕන. Okay? After that, likewise you have can do 4. Is it okay? හරිද? එහෙනම් 2-stage, 3-stage, normally 3-stage එක අපේ යන්නේ 2-stage, 4-stage, 5-stage and 6-stage. Maximum 6-stage එක තමයි යන්නේ. හරිද? එතකොට ওই ටික මම mention කරලා තියෙන්නේ. හරි. ඊට පස්සේ අපි මේ පොඩි questions ටිකක් කරලා තියෙනවා. හරිද? You can go through these things. මේක දන්නවනේ මොනවාද? Non-pipeline ඒ කියන්නේ clock cycle is time t. If the clock cycle එකේ time එක t, 5-stage pipeline 2 task. Task දෙකයි තියෙන්නේ. හරිද? Instruction 2 instructions are there. 5-stage pipe එක stage එකට එක clock time එකක් යනවා. හරිද? ඒතර කොහොමද වෙන්නේ? non-pipeline එක වෙනකොට එක instruction එකකට 5t කාලයක් යනවා. 2 instruction means 10t කාලයක් යනවා. Okay, that is the non-pipelining stage. Pipeline එකේදී මොකද වෙන්නේ? Pipeline එකේදී එක instruction එකකට 5t කාලයක් යනවා. හරිද? For first instruction 5t, අනිත් instruction එකට කොච්චරද යන්නේ? මේ බලන්න. Here you can see there only 2 instructions are there. හරිද? instructions දෙකක් තියෙනවා නම් පළවෙනි මෙන්න මේ කාලය තමයි t කියන්නේ. Okay? Here you can see there are 6 stages are there. The total time එක කීයද එක instruction එකකට? 60. එක ස්ටේජ් එකකට කාලය T නම් for a one instruction, for first instruction to complete first instruction, how much of time taken? This is the T60 time. එතකොට දෙවැනි එකට මොකද වෙන්නේ? 60 ම යනවාද නෑ, only T taken. ඊළඟ T එකේදී ඊළඟ ස්ටේජ් එකේදී ආයිවරයි සෙකන්ඩ් එක. එහෙනම් 6T plus T only. හරිද? Is it okay? එක පළවෙනි ඉන්ස්ට්‍රක්ෂන් එකට හිතන්න ඔයාගේ මේකම අපි ගමු. හරිද? 6 stages, 6 stage pipeline. For a one stage it takes time T. එහෙනම් for a one instruction to complete 6T is taken. නේද? 6T කාලයක් යනවා first instruction එක complete කරන්න. For a second instruction මොකද වෙන්නේ? මෙයාගේ 5T මාරිය ඇතුලේ තියෙන්නේ. Only next T is in that means second instruction is complete within the next stage. එහෙනම් මේ 60 වලට තව T එකක් විතරයි second එකට යන්නේ. Is it okay? Because within the next stage that second instruction is completing. Okay? Another in the third instruction is completing with the other stage. Next stage. ඊළඟ එක හැම stage එකේදී මොකද වෙන්නේ? එක instruction එක complete වෙනවා. හරිද? So that means when we are doing the pipelining time duration, how we can calculate. For a one instruction it is 5T time, and the second instruction it takes only one stage time. It is T. That means 60. So මේ තේරෙනවා ඔයගොල්ලන්ට. Non-pipeline takes 10T and for the pipeline takes 60. The pipeline take for the throughput for a whole time duration is less than the non-pipelining one. ඒනට එකකට යන කාලේ මේ 5T මයි දෙකේම. හරිද? එහෙනම් for a whole task, when we are considering the whole task, pipeline is effective. Okay. එතකොට මෙතන තියෙනවා speed up ratio එක හොයන්න. Speed up ratio, how we can find out? Consider K segment pipeline. Segments K තියෙනවා. Okay, stages K තියෙනවා. Operating on n data set. That means n number of instructions are there. එතන පළවෙනි එකට කොච්චර යනවද? K. Okay, consider K segment pipeline. එහෙනම් K time is taken for a complete to 5. It takes K clock cycle to fill the pipeline and get the first result from the output. First result එක ගන්න K clock cycles යනවා. හරිද? K stages, K clock cycles යනවා. ඊට පස්සේ n number of data set නේ තියෙන්නේ. තව කොච්චර ඉතුරුද? n-1 results තියෙනවා. n-1 results හැමතිස්සෙම මොකද වෙන්නේ? හැම clock cycle එකේදීම එළියට එනවා එක එක. නේද? එහෙනම් K plus n-1 clock cycles need to complete the whole task for the pipeline. හරිද? K plus n-1. තේරුණාද? මෙන්න මේක තමයි හොඳට තේරුම් ගන්න ඕනේ. හරිද? ඉවර වෙන හැම ස්ටේජ් එකේදීම එක එක එළියට එනවා. Okay? To complete the first instruction, it takes K clock cycles. To complete the other n-1, තව remaining තියෙනවා n-1. ඒ n-1 මොකද වෙන්නේ? එකකදී එකක් වෙන්න එළියට එනවා. එහෙනම් n-1 clock cycles need to complete n-1 data instructions. That means K plus n-1 gives that whole set.
Madam?
Yes.
Madam, මෙතන මේ ඔය ගානේ n කියලා කියන්නේ මොකද්ද madam?
N
Instruction
means sorry?
n කියන්නේ
N
instruction.
means the total number of instructions. N data set නේ තියෙන්නේ. That means total number of instructions.
හරි madam.
හරි. That means this one. හරිද? Here instruction 1 2 3 likewise here 9 instruction. 9 data sets are there. හරිද? මේ වගේ n තියෙනවා. හරිද? එතකොට first එක complete වෙන්න මේ 6 time යන්නේ 6 clock cycles යනවා. second එකට කොච්චරද යන්නේ? 6 plus 1 clock cycle. හරිද? එතකොට ඒ වගේ 9 එකට කොච්චරද යන්නේ? first one එකට යනවා 6 clock cycles 9 වලට තව කොච්චර අපිට complete කරන්න තියෙනද? එකක් ඉවරයි. එහෙනම් 9 minus 1 8ක් තියෙනවා. එහෙනම් clock cycles stages 8කදී ඉවර වෙන්න ඕන. 1 2 3 4 5 6 7 8. ඒ හැම ස්ටේජ් එකේදීම එක clock එක instruction එකක් finish වෙනවා. Okay. එහෙනම් පළවෙනි instruction එකට තමයි total time එක යන්නේ. දෙවෙනි stage එකේදී දෙවෙනි එක finish වෙනවා. For the other stage third one හරිද? ඒ වගේ හැම ස්ටේජ් එකේදීම එක එක ඉන්ස්ට්‍රක්ෂන්ස් ෆිනිෂ් වෙනවා. එහෙනම් මොකද වෙන්නේ? පළවෙනි ඉන්ස්ට්‍රක්ෂන් එකට යනවා 6 number of clock cycles for each another. ඊට පස්සේ බලන්න තව කොච්චර remaining ද කියලා. ඒතර මෙතන 1යි 9ක් තියෙනවා 8ක් remaining. එහෙනම් 8 each 8 stages complete each and everything. හරිද? එතකොට මෙතන 6 plus මෙතනට 8ක් එන්නේ. Any questions? හරිද? ඊට පස්සේ speed up ratio කොච්චර speed වෙනවද මේ pipeline එක හැදුවා හින්දා. Okay? ඒක කොහොමද හොයන්නේ? This is divide that here NK means which one? NK means non pipeline. Pipeline එකක් නැති වුණොත් කොච්චරද? K number of stages are there, K segment pipeline. හරිද? ඒ කියන්නේ K clock cycles for each instruction. එහෙනම් n data set, n instructions are there. NK means the total time taken for that one. හරිද? For the non-pipeline in one. For the pipeline in K plus n minus 1. That is the speed up ratio. Pipeline එක හැදුවම කොච්චර speed වෙනවද කියලා අහන්න. Speed up ratio is the ratio between maximum time taken to non-pipeline process over the process using the pipeline. Non-pipeline time divided by the pipeline time. Time taken for non-pipeline divided by time taken for pipeline. That is the speed up ratio. හරිද? Is it okay? Hari. එතකොට so here some measurements are there. Efficiency. So that efficiency we can calculate like this. N divided by K plus N minus 1. That is the way we have to take as that efficiency. Okay. Throughput means efficiency divided by the time taken. Hari. මේ වගේ question එකක් අපි බලමුකෝ. ඒ වගේ එකක් තමයි එන්න පුළුවන්. හරිද? From this type. In that pipeline. Here you can see a non-pipeline system takes 60 nanosecond to process a task. එතකොට එක task එකකට 60 nanosecond යනවා. The same task can be processed in 6 segment pipeline with the clock cycles of 10 nanosecond. හරිද? 6 segment නේ. 6 segment pipeline නේ clock cycle එකක් 10. එතකොට එක task එකක් ඉවර කරන්න කොච්චර යනවද? 60 nanosecond. හරි නේද? Okay. එතකොට මේ 10 nanosecond කියන එක දෙන්නේ නැතුව කියයි the same task can be processed in 6 segment pipeline. එතකොට එකකට යනවා නම් task එකක් කරන්න 60 යනවා නම් 6 segment pipeline එකක් හදනවා නම් කොච්චරද clock cycle එක? 10 nanosecond. Okay, so likewise you have to do the calculation. Determine the speed up ratio of the pipeline for 100 tasks. හරිනේ speed up ratio එක අහන්නේ. එහෙනම් non pipeline time taken එකයි pipeline time taken එකයි තමයි හොයන්න තියෙන්නේ. හරිද? it is easy. Time taken for non pipeline for 100 tasks. එක task එකකට කොච්චර යනවද? 60 nanosecond. 100 tasks are there. That means 100 into 60. Okay, so that is the non pipeline in time taken. එතකොට pipeline in time taken එකේ ඔන්න එතන වැදගත්. හරිද? එක task එකකට කොච්චර යනවද? 60. නේද? එක task එකකට යනවා 60. හරිද? remaining task කොච්චරද? task තියෙනවා 100. remaining ගාන කොච්චරද? 99. නේද? එතන 99 into 10 යනවා අනිත් එකට. හරිද? එතකොට අපිට කොහොමද එන්නේ pipeline in වලද? 6. හරිනේ? පළවෙනි එකට stages 6යි. Okay, එක time duration එකකින් වැඩි කරන එක එළියට ගන්න. හරිද? එහෙනම් 6 යනවා පළවෙනි එකට. 6 clock cycles. 6 clock cycles පස්සේ පළවෙනි task එක ඉවරයි. තව කොච්චර task ඉතුරුද? 99. 100 minus 1. අරකේ වගේ n minus 1. Okay? එතකොට 99 task යනවා. එතකොට 99 වෙලාවෙදී 99 ටික එළියට එනවා. හරිනේ? complete වෙනවා. එහෙනම් එක stage එකක් 10 නම් multiply by 10. Is it okay? So that much of time taken. ඊට පස්සේ speed up ratio means 6000 divided by that one. හරිද? හැමතිස්සෙම speed up ratio එක මොකද වෙන්නේ? greater than 1. Okay? If the pipeline is efficient, that means it should be greater than 1. Hari, any questions?
Madam.
Oh.
Madam, දැන් මේකේ අර 6 segment pipelining කිව්වහම ඒක නිසානේ දැන් අපි 6යි කියලා ගත්තේ. අර මැඩම් 2018 එකේ අපිට දැන් අඳින්න තිබ්බනේ 4 stage pipeline එක. එතකොට ඒ වගේ එකකදී අපි ගන්නේ මේ segments ගාන 4යි කියලා.
Yes. 4 segment.
හරි මැඩම් හරි.
එතකොට එක task එකක් ඉවර වෙනවා 4කින්. segments stages 4කින්. හරිද?
හරි මැඩම් thank you.
හරි. එතකොට එක ටාස්ක් එකකට ක්ලොක් සයිකල් එක 10 නම් එක ටාස්ක් එකක් ඉවරන කොච්චර යනවද? 40 nanoseconds. stages 4යිනේ. හරිද? 40 nanoseconds යනවා. හරිද? සමහර වෙලාවට තියෙනවා හරිද ඊට වැඩි එකක් මෙහෙම ඒ වගේ මට මතකයි question එකක් අපිට තිබුණා කොහේ හරි මට මතක නැහැ කොහෙද කියලා. හිතන්න මෙන්න මෙහෙම එකක්. හරිද? මේ එක ටයිම් එකකට මෙයාගේ යනවා 10 nanosecond. හරිද? second stage එක වෙන්නේ යනවා 20 nanosecond. okay? හරිද? first stage එක ඉවර වෙන්න හොඳට අහගන්න මේක. first stage එක ඉවර වෙන්න 10 nanoseconds යනවා. second stage එක ඉවර වෙන්න 20 nanoseconds යනවා. It is not in equal time durations. okay? third එක ඉවර වෙන්න 10 යනවා. okay? එතකොට අපි කොහොමද ගන්නෙ? එතකොට කොහොමද ගන්නෙ? මෙයාගේ මේ මෙතන පළවෙනි එකේ 10 හරි. okay? ඊළඟ හැම අවස්ථාවෙදී මොකද වෙන්නේ? මෙයාගේ second එකේ 20 නම් මෙයා 20 වල ඉවර වෙනකම් මෙයා ඉන්න ඕන නේද? අනිත් stage එකට යන්න බෑ නේද? okay? මෙයා 20 නම් හරිද? in the second stage takes 20 time. 20 seconds යනවා නම් මෙයා 20ක් ඉවර වෙනකම්ම second instruction එකේ ඒ stage එකට යන්න බෑනේ. ඇයි ඒ process එක function වෙනවා. මෙයා පළවෙනි stage එක තත්පර 10න් ඉවරුණා කියලා මෙයාට යන්න බෑ ඊළඟ stage එකට. මොකද වෙන්නේ? second process එක already functioning. හරිද? අන්න ඒ හින්දා අන්න ඒ වගේ වෙලාවකදී මොකද ගන්න ඕනේ? maximum time duration we have to consider. හරිද? එතකොට ඒ clock cycle එකක time එක කියලා ගන්න ඕනේ maximum එක. හරිද? ඒතර 10 20 නම් 20 තමයි අපි ගන්න ඕනේ හැම clock cycle එකකටම time duration එක. මොකද ඒක තමයි effect වෙන්නේ හැම එකටම. තේරුණාද?
ඒ කිව්වේ මැඩම් ඔක්කොම මේ ඒ කියන්නේ හැම සෙග්මන්ට් එකකම එකකටම අපි 20යි කියලාද ගන්නෙ?
හැම සෙග්මන්ට් එකකටම 20යි කියලා ගන්න ඕනේ. ඇයි මොකද වෙන්නේ? දැන් මෙයා දෙවෙනි එක්කෙනා 20ක් වෙනකම් පළවෙනි එක්කෙනා වෙයිට් වෙනවා. හරිද? ඊට පස්සේ ඒ 10 හැම එක්කෙනාටම ඉෆෙක්ට් වෙනවා නේද? ඊට පස්සේ මොකද වෙන්නේ? දැන් මෙයා 20කින් තමයි මෙයා පටන් ගන්නෙ. හරිද? ඊට පස්සේ දැන් third එක්කෙනා process එක තව ගන්න 10කින් ඉවර වෙනවා කියලා. ඒ වුණාට second එක්කෙනාට අරකට යන්න බෑ. second එක්කෙනා අර process එක ඉවර නෑ එතකොට. හරිද? ඒ හින්දා අර maximum time duration එක තමයි consider කරන්න ඕනේ හැම වෙලාවෙදිම. මම මේ බැලුවේ වගේ එකක් කොහෙද තියෙන්නේ කියලා මට මතකයි කොහේ හරි එක්ක මම questions වලද කරාද? මතක නෑ කොහේ හරි තිබුණා හිම question එක. here මෙතන තියෙනවා. in the 2019 question paper තියෙනවද ඔයගොල්ලන්ට? 2019 question paper එක තියද? answers නැද්ද? question paper එකේ හරිද? I haven't the soft copies. නැත්නම් මට share කරන්න තිබුණා. I haven't it, only hard copies I have. හරි. එතකොට මෙතන තියෙනවා consider the pipeline having 4 phases with duration 60, 50, 90 and 80 nanoseconds. This is not in equal time duration. හරිද? Each and every phases consider unequal time duration. Okay, consider the pipeline having 4 phases. 4-stage pipeline is there. Each and every stage consists for the first stage 60 nanosecond, second stage 50, third stage 90, and last stage, fourth stage is 80. There is saman time duration නෙමෙයි තියෙන්නේ. හරිද? They are giving the latch delay also 10 nanosecond latch delay එකක් තියෙනවා. Latch means that register delay pipeline cycle time එක හොයන්න කියලා තියෙන්නේ. හරිද? pipeline cycle time එක. Okay. So how we can find out the pipeline cycle time? Pipeline cycle time we have to find out. Pipeline cycle time. Cycle time එක හොයන්න කියලා තියෙන කොහොමද හොයන්නේ? එක cycle එකක time එක කොහොමද හොයන්නේ? How we can take 60, 50, 90 and 80. එතකොට time durations හතරක් තියෙනවා. එහෙනම් ඒ හතරෙන් maximum එක ගන්න ඕනේ. හරිද? මොකද මේ maximum time එකේ හින්දා අනිත් ඒවා delay වෙවි ඉන්නවා ඒ time එක එනකම්. Okay? So therefore maximum time duration is 90 nanoseconds. හරිද? එතකොට 90 කියන එක තමයි ගන්න ඕනේ. 90 nanosecond plus 10. Okay? 90 nanoseconds plus 10. තේරුණාද? That is the cycle time. එක cycle එකක time එක. 90 nanosecond plus 10. 10 is the register delay. Delay due to its register. Each and every stage has the register. So register delay එක add වෙන්න ඕන cycle time එකට. Okay, so likewise you have to do the calculation. හරි. ඊට පස්සේ මම මෙතන තව calculation එකක් කරලා තියෙනවා. You have to go through these things. දැන් පුළුවන් ඔයගලන්ට. Time taken to execute without pipeline, time taken with pipeline. Okay, number of instructions n-1. Likewise you can go through those things. මේවා equals දීලා තියෙනවා. හරිද? equal stages. මේ තියෙන 5 stages and 1 instruction issued per clock cycle. එක clock cycle එකකදී එක instruction එකක් issue වෙනවා. But equal time durations are given there. හරි. ඊට පස්සේ list of important factors of pipeline conflicts ඊළඟට එන එක. හරිද? So these are the pipeline conflicts. Okay, නැත්නම් pipeline hazards කියලා අහනවා සමහර වෙලාවට. Okay. Hello.
මැඩම්.
ඔව්.
මැඩම් 2017 පාස් පේපර්ස් වල මේ ඔය pipeline වල ගණන් වල CPI එකයි throughput එකයි හොයන්න තියෙනවනේ. ඒක පොඩ්ඩක්
මොකද්ද?
2017 පාස් පේපර්ස් වල pipeline ගානේ clock cycle එක දීලා විතරක් CPI එකයි throughput එකයි හොයන්න තියෙනවා 4 stage එකේ. එතකොට හොයන්නේ කොහොමද ඒක?
ඊළඟ නෑ ඒක. මොකද්ද
and 4 stage pipeline CPU which has clock cycle of 1.5 nanosecond.
I කියන්න මට
Calculate CPI and throughput of 4 stage pipeline CPU which has clock cycle of 1.5 nanosecond.
ඒකනේ clock cycle එක දීලා.
ඔව් clock cycle එක විතරක්
හරි.
දීලා තියෙන්නේ.
ඉතින් එතකොට කොහොමද එතකොට clock cycle එක දීලා මෙතන අහන්නේ clock cycles per instruction නේ අපෙන් අහන්නේ. නේද? එතකොට 4 stage pipeline එකක්. එතකොට එක stage එකකින් එක clock cycle එකකින් මොකද වෙන්නේ? එක stage එකක් ඉවර වෙනවා. හරිද? එතකොට පළවෙනි එක අහන්නේ අපේ මොකද? CPI ද?
ඔව් මැඩම්.
ඔව් එතකොට clock cycles per instruction. එක instruction එකකට කොච්චර clock cycles 14යිනේ. 4 stage නේ. හරිද? එක ස්ටේජ් එකක් ඉවර වෙනවා එක ක්ලොක් සයිකල් එකකින්. එහෙම නැත්නම් ඒක මෙන්ෂන් කරනවා. හරිද? අර එක අපි ගානක් කරා නේද මොකක් හරි එකක්. එතන මතකද තිබුණා ALU instruction takes 3 clock cycles. හරිද? එතකොට මේ ALU instruction එක 3 clock cycles වලට යනවලු. හරිද? එහෙම මෙන්ෂන් කරනවා එහෙම තියෙනවා. taking මේ මම ෂෙයා කරපු එකේ බලන්න චුට්ටක් බලා ගන්න. මේ one instruction එකේ one cycle එක ඉවර වෙන්නේ මේක clock cycle එකකින්. මේක clock cycle එකකින් එක stage එකක් finish වෙනවා. තේරුණාද? එක stage එකකට යන්නේ එක clock cycle එකයි. Normally. හරිද? If they are mentioning that somewhat different thing, at that time we have to consider that instructions. That data we have to take. හරිද එතකොට? question එක අහපු එක්කෙනා.
හරි madam.
තේරුණාද? goal එක්කෙනෙක් නේද? මට කටහඬින් මේ වගේ goalද?
ඔව් madam.
ඔව්. හරිද? හරිද?
හරි.
නම් මතක නෑ දැන්. හරිනේ? මේ එක clock cycle එකක් හරිද? එක clock cycle එකකින් එක stage එකක් finish වෙන්න ඕන. okay? එතකොට එක දැන් මේකේ කියලා ඔයා කියපු විදිහට මට තේරුනේ clock cycle එකක් 2.5 nanosecond නේද කිව්වේ? 4 stages තියෙනවා. එහෙනම් 2.5 nanoseconds කියන්නේ එක clock cycle එකක time duration එක. එතකොට CPI කියලා කියන්නේ clock cycles per instruction. එක instruction එකක් ඉවර වෙන්න කොච්චර clock cycles ඕනද? එක stage එකකට එක clock cycle එකයි නම් 4 stage නම් 4 cycles ඕන එක instruction එකට. එතකොට clock cycles per instruction is that one. හරිද?
හරි madam.
හරි. okay. ඊළඟට අපි බලමු. හරි එතකොට අපි ඩිස්කස් කරේ conflicts. හරිද? එතකොට මේකේ ඔයගලන්ට පුළුවන්. මේ conflicts ඔයගලන් දන්නවා. I already mentioned those things. This is the branch conditional branch penalty නේද? branch penalty එක. මතකයි නේද? අර branch එකක් මේ වෙනකොට මේ මොනවද දැන් හිතන්නකො මෙතෙන්දී. okay here execution at that execution instruction මේ execution එකේදී branch එකක් appear වෙනවා. හරිද? එතකොට branch එක appear වෙනවා. ඉතුරු instructions ටික already perform වෙලා තින්නේ. ඒ branch එකේදී මොනවාද? ඒ branch එකේ මේ value එක write back කරන්නේ මෙතෙන්දී. හරිද? එතකොට write back කරාම sorry මේ fetch operand එක fetch වෙලා මෙතන execution එක වෙලා හරිද? මේ execution එක වුණාම execution එක වෙලා ඉවර වෙනකොට තමයි මේ branch එකේ result එක ඇවිල්ලා තියෙන්නේ. හරිද? එතකොට ඒ result එක ඇවිල්ලා තියෙනවා. ඒ result එක years නම් අපිට ඉතුරු ටික perform කරන්න පුළුවන්. okay if that result is else මොකද වෙන්නේ? එහෙනම් යන්න ඕනේ වෙන instruction එකකට යපනින්න ඕනේ. නේද? else instruction එකට යන්න ඕනේ. හරිද? එතකොට මෙයා else instruction එක කියලා කියන්නේ 15 instruction. ඒ අතරෙම ටික මොකද වෙලා තියෙන්නේ? automatically they are performing. නේද? එතකොට මේ processors වැඩ කරලා. එතනට මේ ටික වැඩක් තියද? නෑ. That is the unnecessary thing. okay unnecessary load is happening there. okay මේතන instruction execute වෙලා ඉවර වෙනකොට තමයි ඇත්තටම result එක එන්නේ. හරිද? result එක years නම් okay. 1 4 5 6 we can follow. හරිද? that results think about it is else part. හරිද? else උනා නම් මොකද වෙන්නේ? ඒක ඊළඟ 15 instruction එක තමයි තියෙන else එක. එහෙනම් මෙතන ඉඳලා else එකට යන්න ඕනේ. හරිද? else එකට යනකොට else එකේ ඉඳලා තමයි දැන් perform වෙන්නේ. ඒතර මේ ටික මොකද වෙන්නේ? they are automatically working. නේද? මේ processors automatically work වෙලා යනට වැඩක් තියද? these are unnecessary load. හරිද? මෙන්න මේ ටික වැඩක් නැති ටික. and that is the major disadvantage of the pipelining. හරිද? conditional branch effects. conditional branch. that is the hazard or the conflict එකක් ඒක. අපරාධයක් නේද? so there you can see it is the flushed instruction. මේ instructions ටික මොකද වෙන්නේ? flushed. වැඩක් වෙන්නේ නැහැ අපිට flushed instruction. okay so branch here branch taken. so else that means branch go to the 15th instruction. now it is processing there. මේ මෙතනින් තමයි execution එකෙන් තමයි result එක එන්නේ. එතනින් පස්සේ යනවා 15 instruction. එතන මේ ටික මොකද වෙලානේ? flushed instruction. this is we are calling branch effect. okay okay this is the conditional branch and those are the conflicts. Timing variation, data hazards, I already mentioned those things. That is interrupt branching, interruption and data dependency. Okay, so normally that data hazard means that several instructions are in partial execution that reference same data. That means example make a resource hazards. Okay, resource hazards. So the normally that conflicts and the hazards are both same. Okay, so normally structural hazard, data hazards, and the control hazards. Structural hazard means the hardware conflicts. Hardware conflicts eva ඇති වෙනවා. හරිද? hardwares මොකද shared hardwares use කරන්නේ. එතකොට shared hardwares වලින් මොකද වෙන්නේ? එකම hardware එක සමහර වෙලාවට ඕන වෙනවා. එක එක stages වලදී එකම same hardware need to be used in the same stages. හරිද? එතකොට ඒ වෙලාවේදී ඒ hardware එක use කරගන්න බෑ අපිට. හරිද? That is we are calling the structural hazard or the hardware hazard. And data dependency. හරිද? data hazards. ඒ කියන්නේ එකම data එක ඕන වෙනවා කීප සැරයක් එකම වෙලාවෙදී. Okay, same data need to be accessed in the same time. ඒතකොට මේ data එක තියෙන එකම memory location එක. ඒතර මේ memory location එක access කරන්න පුළුවන් එක වෙලාවට එක්කෙනාට. ඒතර අනිත් ඒවට අනිත් location අනිත් stages වලට ඕන වුණා කියලා access කරන්න බෑ. So that is data hazards. හරිද? Other one is the control hazards. Control hazards means normally the branches, jumps, those are the we are calling the control hazard. හරිද? එතකොට මේ data hazards ඔය වගේ වෙනවා නම් මොකද අපි කරන්නේ? මෙන්න මේ වගේ bubbles insert කරනවා. Okay, bubbles, initiation bubbles, delay set කරනවා. හරිද? හිතන්න මේ දැන් මෙයා perform වෙනවා ඉස්සෙල්ලා. හරිද? ඊළඟට දැන් මොකද්ද ඊට පස්සේ ඊළඟ එක්කෙනාගේ හිතන්න දැන් ඉස්සෙල්ලා මෙයා perform වුණා. දෙවනි එක්කෙනාට දැන් මෙයා perform වෙන්න කලින් මේ තියෙන stage එකේදී මේ ඊළඟ එක්කෙනා එනවා perform වෙන්න කියලා. එතකොට මෙයාටත් ඕන වෙනව නම් අර structure hardware එකක් හරි data එකක් හරි අනේ වෙලාවෙදී යාට මොකද කරන්නේ? යා මොනවත් perform කරන්නේ නැතුව අපි යාට empty space එකක් දෙනවා. delay එකක් add කරනවා. හරිද? මේ stage එකේ එන්න එපා. එතෙන්දී delay එකක් add කරනවා. ඒක normally කරන්නේ according to the priority. හරිද? according to the priority they are adding the delays. එතන මේ stage එකට කලින් මෙයා perform කරන්න හදනවා. ඊළඟ instruction එකේ මේ stage එක perform කරනවා. ඊට පස්සේ තමයි අපි ඊළඟ stage එක perform කරන්නේ. හරිද? adding some delays into the system. delays add කරනවා. they are we are calling the bubbles. හරිද? එතකොට මේ hazards අඩු කරගන්න මොකද කරන්නේ? initiating the delays add කරනවා. නැත්නම් more resources allocate කරනවා. හරිද? more resources allocate කරනවා. that is one method. And adding delays into the flow, that is another method. Those are the normally we can remove hazard from using those things. Okay, conflicts also same. Data dependency, interrupts මොනවා හරි අපිට අවශ්‍ය නැති දේවල් තියෙනවා නම් some interruptions are given. And branching effect, data hazard and the timing variation. So those are pipeline conflicts. So hazards key mentioned kalla tiyena data hazards. There are normally that read after I try it after this. You can go through each and everything. Okay. Here these are the two solutions to the data hazard. That bypassing. That means adding some delays. Okay. This is that forwarding. Forwarding means the forwarding hardware use. Hardwares that we can add hardwares to that one. And that stalling. Stalling means the pushing back. Adding some delays. Okay, adding some delays into the system. We can push back that whatever the stage into the another stage. So those are the major solutions. Control hazards. Here. Anything regarding that pipeline? මොනහරි එතකොට 2018 paper එකේ දිගටම fourth එකත් එහෙම stage 3 instruction pipeline question එක කරන්න පුළුවන්. Briefly describe each hazards in the instruction pipeline. Okay, එතකොට hazards අහලා තියෙන්නේ. You can write the hazards you can mention. හරි ඊට පස්සේ මම කිව්වා අර දැනකදී අහුවා නේද අපිට risk and CISC. Okay, so here you can see what is the risk and the risk means the reduced instruction set. CISC means the complex instruction set computer. Okay, so reduced instruction set means faster and simpler hardware, more instructions per program. Complex means slower, complex instructions set. Complex hardware are there and the slower. So I think I here mentioned some there risk and the CISC architectures. Here I mentioned what are the differences. Okay, differences between RISC and the CISC architecture. එතකොට briefly describe the features of the CISC and RISC. එතකොට ඔයගලන්ට පුළුවන්. Here you can see those are the features. RISC is the faster and the simpler hardware is using more instructions per program. CISC means complex. Complex hardwares are using slower. Complex means slower the program, fewer instructions per program. Okay, because that more complex hardware are using there. So that means using fewer instructions can perform whatever the same task. This is about the RISC and the CISC. Okay, go through those things and get the ideas. Hari. ඊළඟ එක next one normally they are following that MTBF and MTTF. නේද? ඔය ටික නම් දාන්න ඕගොල්ලෝ. Mean time to response, mean time between failure. MTTM means mean time to acknowledge. Okay. Or MTTR, it also can get mean time to response. I think here microprocessor reliability. Okay, failures. That reliability means which one? So how that system is reliable. Okay, so that means failure rate. What is the failure rate? If the failure rate is low, that means we are calling it is the reliable system. So this is normally we are calculating here. And there you can see mean time between failures. Mean time between failures. Failures dekak atara mean time එක. Okay. So total operational uptime between failures divided by number of failures. Okay. So from there you can take here you can see that start of downtime minus start of uptime. එතකොට මෙන්න මෙතන තමයි මේ මොකද වෙන්නේ? There one failure is occurred. Because this is the operate. Any questions? So this one is that uptime of this uptime. හරිද? මෙන්න මෙතනදී තමයි up වෙන්නේ operate system එක. So this is the operational time. And again what happened? Next failure is occurred. Okay. So between, that is the time between two failures. Between failures. Time taken between failures. හරිද? mean time between failures. Failures දෙකක් අතර mean time එක. Okay, that is the between failures. Time taken between failures. Okay, so එතකොට මොකද කොහොමද ගන්නෙ? So if we are taking the repairable system, MTBF we are calculating for the repairable system. Repair කරන්නනේ failures වැඩි වෙන්නේ නේද? For the non-repairable system, what happened? එක failure එකයි වෙන්නේ, එතනින් system එක අයින් කරන්න. So MTBF we cannot calculate for the non-repairable system. For a repairable system, we can calculate the MTBF because several failures are occurred. Time taken between failures we can calculate. The summation of start of downtime minus start of uptime. Downtime making uptime operational time. හරිද? ඒ වගේ summation එක කොච්චර operation time එකක් තිබුණාද, number of failures කොච්චර failure එකක් වුණාද, that gives the MTBF. Is it okay? එතකොට here one question is there. මේ තියෙන්නේ first failure number පළවෙනි failure එක recorded operational uptime before failure කොච්චරද 10000 කාලයක් operational time එක. second failure එක දී කොච්චරද 9500. හරිද? likewise. එතකොට total number of operational time එක 39500. කොච්චර failures වෙලාද ඒ අතරේ? 4 failures are happening. So total time duration by the 4 means the MTBF. Likewise, you can calculate BF. Okay. ඊට පස්සේ MTBF එක දන්නව නම් we can calculate which one? That MTBF is the 1 over lambda. So lambda is the failures per unit time. That is the failure rate. Lambda is the failure rate. Okay. So if you know the MTBF, 1 over lambda gives the failure rate. MTBF equals 1 over lambda. Lambda is the failure rate. So failure rate also you can calculate. The lambda is the failure rate. So this is the mean time to failure. So normally this is that rate for the replaceable products. Okay, non-repairable system. That means some parts we can replace. So for there we are calculating mean time to failure. Mean time to failure. This replaceable product that can't be repaired. Repair karanna bahe, but we can replace parts of the parts. Okay, so those things you can go define the term MTBF, defining the terms. And some MTBF calculations normally they are asking. Here failure in time. One question also mentioned there. Okay, so that normally process errors we can divide into these things, soft errors and the hard errors likewise. Here bathtub curve is mentioned. I mentioned all the things. These are theory parts. Next thing I want to mention some fault. Fault unconventional fault finding techniques likewise. Okay. So here that faults are mentioned in there. Normally that microprocessor based faults can be like this. Okay, chip failure, open circuit interconnection, bridging or short circuit interconnection, externally induced interference, or the original software bugs. The original software bugs also there. But it can be identified after several times ago. ඒ කියන්නේ හැම එකටම නෙමෙයි කීප එකකට විතරක් ඇති වෙන්න පුළුවන් බග් එකක්. ඒතර ඒවා identify වෙන්නේ ගොඩක් කාලයකට පස්සේ. Okay, after 5 years, 3 years likewise. මේ දවස්වල recently වුණා මොන හරි phones જાතියක් මතකද? ඔයගොල්ලන්ටත් සමහරට observe වෙන්න ඇති. phone මොන හරි Oppo හරි මොන හරි I can't remember the phone, that name of the phone. That phone has the original software bugs. හරිද? එතකොට ඒවා ආයි මොකද කරේ? company එකෙන් return අරගෙන මේ මගේ හිතේ මොන හරි කරා. හරිද? So likewise. So that at that time at the under testing condition that those bugs are not presenting, but after using those things some bugs can be present. Hariද? Original software bugs. And those are the typical failures. Faults can be happen in the micro-based system. Chip failure, open circuit interconnection, bridging or short circuit interconnection, externally induced interference, and the original software bugs. That's chip failures. Chip එක fail වෙනවා. නේද? So those are the that happen in instances. හරිද? Likewise you can go through. මේවා නම් නිකම්ම කියවලා ගන්න තියෙනවා. Okay, open circuit interconnection. So in this segment also normally they are asking one question. ඊට පස්සේ how we conventionally fault finding techniques. Normally in the fault finding techniques we are dividing into two segments, conventional and the non-conventional. In the conventional means, these are the conventional methods. Visual inspection from our naked eye, we can inspect are there any that short circuiting thing and that open circuiting thing likewise, and DC test and the oscilloscope from the CRO. At the normally api lab එක කරන්න ඔය ටික නේද? Visual inspection, DC test and the oscilloscope. So those are the conventional fault finding techniques. Are the each and every step I mentioned there. Okay, DC test එක multimeter එකෙන් කරන්න පුළුවන්. From the oscilloscope also we can measure. And non-conventional means we are using the special test equipments. Okay, if we are using the special test equipments, those are the non-conventional fault finding techniques. Normally logic probes, logic pulses, current tracer, likewise. The logic probe I already mentioned. There is the indicator lamp. That indicator lamp shows some indicate if there is any which one that there it should be there that you can see that according to the light, according to the color of the light, you can go through. You can identify what is the fault there. Okay, so that is the logic probe. And here logic pulsar is there. So logic pulsar means we give pulse to the gate, and from the logic probe we can identify are there any faults or not. Logic gate එකට අපි pulse එකක් දෙනවා. හරිද? From using the logic pulsar. The output එක we know. We can observe the output. If that output is not the required output, we know that it is the fault in the logic gates. Okay, so likewise we can find out. The current tracer, logic analyzer. So those are the non-conventional fault finding techniques. Some special equipments. Explain two equipment used in non-conventional fault finding techniques in microprocessor. Briefly explain the 3 faults in microprocessor based system. So those things you can go through. ඊළඟට normally අහන එකක් තමයි system development life cycle. System development life cycle. System development life cycle also I already mentioned that one. ඊළඟට ඔයගලන්ට මේ එකත් අහනවානේ මොකද OS classifications ගොඩක් වෙලාවට අහනවානේ නේද? That compiler linker හරි දේවනම් ඔයගලන් දන්නවා. Okay, so this stuff. Operating system, normally 5 operating functions are there. මේවා IT වලටත් ඉගෙන ගන්නවා නේද? Memory management, processor management, device management, file management and security. හරිද? So here we are normally process scheduling is doing. The process management. ඊට පස්සේ මේක ගොඩක් වෙලාවට අපෙන් අහනවා මෙන්න මේ ටික. හරිද? Some write the short notes of compilers, linkers, assemblers, loaders like this. Okay, so you have to go through these things. ඒවා ගොඩක් වෙලාවට මේ read කරගන්න. Okay, so linkers means link a program required to produce executable files likewise. Okay, debugger, testing, the debugging. So editor, so that we are writing the source code in the editor. And there are types of translators, compilers, interpreters, likewise. Okay, so compiler means which one translate that high level language to the low level language. Compiler. Interpreter means high level language to low level language, that also same, but what one? Line by line translation is done through the interpreter. Mention here interpreter, you can see line by line translation. Okay, එක line එකක් යනවා එයා syntax එකක් දෙනවා likewise. Okay, error එක correct කරාට පස්සේ තමයි it moves to the other line. That is the interpreter. In that compiler means all the set, all the program run through the compiler and all the errors are indicating. All the errors are indicating at once. It is the compiler's one. Compiler and interpreter, here you can see compiler execution is faster because all the things are there. For the 2000, please madam discuss the PLD question for 2018 6 question. PLD නම් මම ඩිස්කස් කරන්න ඕනේ නැහැ. මම ඔයගලන්ට කරානේ හොඳට මේක. PLD ඩිස්කස් කරනවා කියන්නේ මේක ලොකුම ටාස්ක් එකක් වෙනවා. PLD no need to discuss. PLD මම questions කීපයක් කරානේ. Please go through that one. PLD එක නම් අදක discuss කරන්න අමාරුයි දැන්. ඒකේ මොකද මම ඇඳ දෙපයි කරන්නේ. නේද? මම බලන්න lecture note එකේ මොන හරි තියෙන එකක් discuss කරලා දෙන්න. මම හිතන්නේ මම board එකෙත් කරා PLD එක. Lectures ආවන you know those things. හරි මෙතන compiler interpreters එතකොට එතන තියෙනවා loaders හරිනේ මේ ටික go through මෙන්න මේක තමයි අනිත් එක process scheduling හරිද normally that I think මම දැක්ක questions කීපයක අහලා තියෙනවා what is the process scheduling write the 3 types of schedulers likewise okay process scheduling again so normally that in the process scheduling means here you can see that is the status of the process. Okay, process status are mentioned there. New, running, waiting, ready, and terminator. So those are the processes happening in the process scheduling. Okay, so here you can see block diagram of the process management of the OS. Process status are mentioned there. New, okay, new process is creating, and it moves into the ready state. හරිද? ඊට පස්සේ ready state එකෙන් මොකද වෙන්නේ? It moves into the run state. If some interruptions are happening, it moves into again ready state. Okay. If not, if that running state is need to wait for IO devices, it needs to go for the waiting. Okay. So likewise, it moves. And after running state, it exit, alter. So these are the 5 states present in the process scheduling. New, ready, running, waiting, and the holding. Okay, so there you can see new. The process is being created. Running, instructions are being executed. Waiting, the process is waiting for some event to occur. IO devices willing output එකක් ඕනේ නම්. Okay, if some events are occurring, that process should be wait. Ready, the process is waiting to be assigned to a processor. Termination, process has finished the execution. Okay, so that is the major states of the process scheduling. The process scheduling ගැන හවොත් ඔය ටික තමයි විස්තර කරන්න ඕනේ. You have to draw this diagram. It is better block diagram. It is easily you can explain this stuff. හරිද? These are the process scheduling. තව මොකක්ද කියන්නේ අනිත් එක තමයි system development life cycle normally they are asking ඒකම ගොඩක් වෙලාවට අහනවා system development life cycle එකත් SDLC it's like this. Okay, system development life cycle. So there are those things you have to go through. These are the 7 phases in the system development life cycle. System එකක් develop කරනකොට මොකක්ද අපි follow කරන්න ඕන method එක. Okay, what are the sequences we have to go? What is the procedure we have to follow? So first thing is the planning. We have to go for the planning stage. After that, analysis, and design stage, development, testing, and implementation, and the maintenance. I think I draw this one. Here you can see this is the system development life cycle, SDLC. Okay, first thing is the plan karanna ඕනේ. ඊට පස්සේ analysis, design, development. Okay, design එකේදී development කරද්දී ආයෙ ඔයගලන්ට හිතෙනවා it can be changed to this one. Then again you can go for the analysis and design likewise. Okay, after development you have to test that one, and implementation, maintenance likewise. Again planning these things. හරිද? එතකොට මේ ටික කියවන්න. These are the that briefly discussion. The brief discussion also, and there are that system development methodologies are there. Waterfall method, rapid application development. Okay, මේව නම් බොරු ලොකුවට අහන්නේ නැහැ. හරිද? waterfall method means one after the other, like a waterfall. හරිද? planning කරාට පස්සේ total plan එක ඉවරනහම තමයි analysis එකට යන්නේ likewise. Okay, waterfall method. This is rapid application development is this one. Planning and analysis is one stage. And design, development, testing, and design. This one is the that all the three is in the next stage. හරිද? ඒතර development කරන අතර test කරලා design කළා ඔය ටිකම එකට කරන්න. After that, implementation and the maintenance. Okay, that is the rapid application development. Here you can see the extreme programming. It is that all the other that 5 stages are in the same. So මේව වෙනස් වෙවි යන්න පුළුවන්. Planning and the maintenance are in the separate format. හරිද? Likewise. Okay, so those things you can go. හරිද? ඒතර ඔය ටික තමයි SDLC වල major one එක. Okay, so there are normally 7 phases are there. So each and every phases are linking like this as a life cycle, and that what are the brief discussion of the each and every phases. And there are several methods to follow, waterfall methods, rapid application method likewise. Okay. It is SDLC. Process scheduling. And it that explain the file system, fact, NT-fact, NTFS likewise. You have to go through there. And it is PLD. PLD now, it is very difficult to do that one. Now, mama board එකෙත් කර දවස් කියලා දුන්නා ඔයගොල්ලන්ට. The programmable logic devices. PLD වලට ආව නම් okay, programmable logic devices. So here that make තමයි major එක. Okay, so there are 3 PLD devices: PROM, PAL, and the PLA. So the PROM means programmable read-only memory. Normally that first stage is the AND array, second stage is the O array. Okay, in the PLDs, first stage is AND array, second stage is O array. එතකොට AND array එක මොකද වෙන්නේ? PROM එකේදී fixed. Okay, we cannot program. මේක ඇත්තටම මේ මොනවාද? අපි program කරන IT software program එකක් නෙමෙයි. Okay, switches, they are normally switches are there. So we are connecting those switches. So that connection type. හරිද? ඊට පස්සේ here programmable O array. We can program the O array. This is PAL means programmable array logic, programmable AND gate, and the fixed O gate. In the PLA, it is the programmable AND and the programmable O. So those are the major 3 types of the PLDs. එතකොට මෙතන here you can see that one. This is the PROM implementation. So to make a cool question. Here is my question. Here you can see that the F1, F2, F3, F4. හරිද? So these are our outputs. F1, F2, F3 and F4. These are our outputs. මේ හතර තමයි outputs හතර. There are two inputs. හරිද? There are two inputs. Inputs දෙකයි. F1 කියලා කියන්නේ A dash B dash. F2 means කියන්නේ දිග මොන හරි මේ මගේ මේක function එක නැහැ. The output however F1 equals A dash B dash. Okay. ඊළඟ F3 එතකොට F1 කියලා කියන්නේ මෙන්න මේ දෙක එකතුව. F1 equals A dash B dash plus A dash B. F1 equals that one. Okay. That is the output F1. F2 equals මෙන්න මේ තුනේ එකතුව. Okay. A dash B plus A B dash plus AB. That is the F2. F3 means these three. Okay, likewise. Those are the four functions, four outputs. එතකොට outputs ගන්නට අනුව තමයි අපිට මොකද වෙන්න ඕනේ? OR gates. Okay, number of OR gates are equals to number of outputs. ඊළඟට number of inputs are equals to which one? Number of input buffers. Number of inputs are equals to number of input buffers. හරිද? ඊට පස්සේ what happened? Here that number of OR gates we can take there. Number of OR gates are equals to according to the min that number of status present in there. හරිද? ඒතර ඔයගොල්ලන් බලන්න උතන F1, F2, F4 means okay, so there that number of input buffers are equals to number of input variables. ඊට පස්සේ number of min terms are equals to the normally AND gates. Number of functions, output functions are equals to the number of OR gates. So likewise, we have to select our hardware parts. Okay, hardwares we have to select according to that one. හරිද? එතකොට මෙතෙන්දී මොකද වෙන්නේ? This one is already fixed. හරිද? මේ ටික fixed. This cannot program. හරිද? මේ වගේ අපිට program කරන්න බෑ. It is already fixed. Okay, so these switches that there you can, this one is already fixed. This side here you can see PROM is which one? Fixed and array. නේද? and එක fixed. ඒ හින්දා මේ ටික already fixed වෙලා තියෙන්නේ. ඒකට අපිට ඕනේවට අපිට connect කරන්න විතරයි තියෙන්නේ. හරිද? Here you can see A comes from this line. This is the buffers. A dash comes from that side. Okay, so likewise you are getting these things. එතකොට මෙතන මොකද වෙන්නේ? This first combination is prepared according to that one. AB equals 0. So AB equals 0 comes from here. හරිද? ඊට මෙතන 0 0 0 1 1 0 and 1 1 we can prepare like this. Okay, so these are the fixed connections. Just according to that one, F1, this we can program. This side we can program. Whether F1, what is F1? F1 equals AB plus AB dash. So මෙතනින් එනවා මේ AND gate එක AB, මෙතනින් එනවා AB dash. A dash B නේ, A dash B. So මේ දෙන්න add වුණාම තමයි F1 හැදෙන්නේ. So these things we can program. මෙන්න මෙතන තියෙන fuses according to our requirement we can on and off. හරිද? So there you can see that min terms, zeroth min term, first min term, second min term, min term 3. Min terms are generating from these AND gates. These AND gates provide the each and every min terms. Here 2 inputs are there. That means 2 to the power 4 min terms are available. So you can prepare 4 min terms from there. So according to the requirement, we can link those min terms and get the output. That is the PROM implementation. Okay. අනිත් ඒවාත් එහෙමමයි. PAL, there we know that which one? That fixed OR gate is there and programmable AND gates we are using. Here you can see these are the F1, F2, F3, F4 outputs. 4 outputs are there. So that means we have to take how many OR gates? 4 OR gates need to be select. Hari isella hardware part එක select කරන්න. 2 inputs are there. So that means 2 input buffers should be there. හරිද? ඊට පස්සේ what happen here? That this thing is fixed. හරිද? O side is fixed. We cannot program. But that AND gate side we can program. Okay, according to our requirement, we can program this side. හරිද? එතකොට when we are programming that one button, here you can see that these sides are fixed. මේව අපිට program කරන්න බෑ. Okay. So according to that one, here you can see F1. F1 is that one. F1 means 0, 0 and 0, 1. 2 inputs are there. So F1, according to that one, you can prepare. Please draw that one of the Carnot maps. You have to draw the Carnot map to simplify. Simplify කළාම තමයි මොකද වෙන්නේ අපි. We can use the minimize logic gates. The minimum logic gates we can use with the simplification. With the simplification. So that for F1, we can draw AB. AB විතරයි අරන් තියෙන එක පැත්තකට. නැත්නම් you can take that AB like that. The four cell Carnot map also you can draw. Here AB take into the one side. එතකොට F1 එකට මොකද වෙන්නේ? AB0 is 1 and here 0 1 also 1. එතකොට මෙයා circle වෙනවා. That minimization happens with which one? F1 equals A dash. F1 equals A dash. හරිද? ඒ වගේ අපිට හොයා ගන්න ඕන required what are the මොනවාද? min terms. Okay, required min terms ටික හොයා ගන්න ඕනේ. හරිද? min terms ටික හොයාගෙන ඉවර වෙලා තමයි we have to select our AND gates. Okay, we have to select our AND gates according to the required min terms. එතකොට F2 මේ minimization එක කරාම මොකද? A plus B. F3 A bar plus B bar. F4 A bar A dash B plus A B dash. Likewise, we are getting that which one that required outputs. හරිද? ඊට පස්සේ we know that in the PAL what happened? That we know that 4 outputs are there. 4 outputs are there. F1, F2, F3 and F4. හරිද? එතකොට මේ outputs 4ම තියෙනවා. 4 outputs නම් මොකද වෙන්නේ? O gates 4ක් select කරන්න ඕනේ. හරිද? O gates 4ක් select කරන්න ඕනේ. Okay? According to the number of outputs, you have to select the output side. Output එක අපි දන්නවා අනිවාර්යෙන් O gates. Input එක මොනවද? Input buffers. Okay? So that 2 input variable, that means 2 input buffers. ඊට පස්සේ මෙන්න මේ ඇතුළේ ටික තමයි අපිට වැදගත්. හරිද? In that PROM, number of min terms are affected to there. According to the number of min terms, we can select the AND gates. හරිද? මෙතනත් same. හරිද? මෙතන බලන්න ඕනේ මෙහෙම එකක්. බලන්න මේ F1, F2, F3, F4. Those are the outputs. හරිද? මේ outputs වලට කොච්චර අපිට මේ මොනවාද min terms add වෙලාද කියලා. For F1, 1 min term. F2, 2 min terms are there. F3, 2 min terms. F4, 2 min terms are there. හරිද? එතකොට අපි අනිවාර්යෙන් O gate එකක් select කරන්න ඕනේ. එක මේ terminal එකක් තියෙන එකක් නෙමෙයි. හරිද? මොකද අපි මෙතෙන්දි select කරනකොට දැන් F1 එක ගන්න පුළුවන් එක terminal එකක් තියෙන එකකින්. හරිද? එක O gate එකේ එකයි input එකයි තියෙන්නේ. F2 එකට අපිට input කීයක් ඕනේ? දෙකක් ඕනේ. F3 එකට දෙකක් ඕනේ. F4 එකට දෙකක් ඕනේ likewise. Okay? එතකොට මෙයාට එකයි මෙයාට දෙකයි මෙයාට දෙකයි මෙයාට දෙකයි එහෙම select කරන්නේ නැහැ. It should be uniform. හරිද? Unique. It should be the uniform. එතකොට දෙක නම් maximum තියෙන හැමෝටම දෙකේව select කරන්න ඕන. හරිද? හිතන්න මෙයාට 3ක් ආවා කියලා තව term එකක් ආවා කියලා. එහෙනම් 3 that input should be 3. හරිද? හැම එකම select කරන්නේ අපි 3 inputs තියෙන OR gates. තේරුණාද? එතකොට මේකේ disadvantage එකක් තමයි ඒක. හරිද? It should be uniformity. එතකොට මෙතන වැඩිපුරම තියෙන min terms ගන්න දෙකයි. එහෙනම් input should be 2. හරිද? inputs දෙකේ OR gates තමයි select කරන්නේ. හරි. ඊට පස්සේ මොකද වෙන්නේ? We have to generate F1. F1 how we can generate A bar. A bar නම් මොකද වෙන්නේ? හරි. ඊට පස්සේ මෙතන inputs දෙකේව select කරා නම් කීයක් total inputs තියෙනවද අපේ? එකකින් දෙකක් තියෙනවා 4 gates තියෙනවා. එහෙනම් 8. එහෙනම් අපි how we can generate AND gates? 8 AND gates should be there. AND gates 8ක් generate වෙන්න ඕනේ. Okay? 8 AND gates should be there. ඊට පස්සේ කොහොමද? F1 හැදිලා තියෙන්නේ කොහොමද? A bar විතරයි. එහෙනම් this should be A bar, this should be 0. එතකොට නේද A bar එන්නේ? හා. එතකොට A bar වෙන නම් this should be මොකද වෙන්න ඕනේ මෙයා? මෙයා මේ A කියන එක නා මේ bar එක තමයි අපි මේ switch කරන්න ඕනේ. හරිද? it should be there. එතකොට මෙයා select කරන්නේ නැත්නම් මොකද කරන්නේ? all the fuses should be fused. අන්තිම මේ හැම එකම fused කරලා තියෙනවා. එතකොට මෙයා මොකද වෙන්නේ? මෙයා normally redundant line. හරිද? redundant gate එකක් වෙනවා. Okay, this is redundant gate. ඊට පස්සේ in the F2 A plus B. එතකොට මෙයා A මෙතන අපි switch කරනවා, B ගන්න මෙතනින් switch කරනවා. A plus B. This line comes A, this line comes B. හරිද? ඒ වගේ හදාගන්න. A bar B bar. එතකොට A bar කියලා ගන්න කොහොමද? This should be A, this should be B bar. හරිද? min terms ටික තමයි create කරන්න ඕනේ. Here you can see A bar B. කොහොමද ගන්න? A bar B comes to here. එතකොට A bar B. Here it comes A bar B. And මෙතන A B bar. A B bar comes there. එතකොට ඒ දෙනාගේ addition එක comes with the OR gate F4. So likewise you can prepare the PAL. Okay, the programmable array logic. Main thing is you have to, which one? Minimization. Use the minimization. හරිද? minimization එක නැති වුණොත් අපේ මේ gates ගාන මොකද වෙන්නේ? It is increasing. හරිද? ඒක increase වෙනවා. මේ බලන්නකෝ F2 වලට. F2 එක ගත්තොත් ඔයාට min terms කීයක් එනවද? 3ක් එන්න ඕනේ. 1 2 3. F3 ගත්තොත් 3 min terms are there. හරිද? F1 වලට 2 min terms, F4 2 min terms. එතන මේ 3 min terms වලට අපි ගන්න ඕන OR gate එක කීයද? 3 input OR gate should be there. එතකොට මෙයාට 3ක් ගන්නවා අපි. මෙයාට 3ක් නම් මේ හැම එකටම මොකද ගන්න ඕනේ? 3 input OR gates. නේද? 3 input OR gates මේ හැම එකටම ගන්න ඕනේ. එතකොට මොකද වෙන්නේ? අපේ circuit එක somewhat spacious. හරිද? circuit එක ගොඩක් අපිට මේ අපිට tiny circuits cannot be created. නේද? space එක ගන්නවා. ඊළඟට cost එක වැඩි. දැන් මෙතන දෙකෙන් කරගන්න පුළුවන් ද තව input terminal එකක් අපි මෙහෙම දාන්න වෙනවා. හරිද? minimize කරේ නැති වුණොත්. එතකොට ගොඩක් space එක ගන්නවා. හරිද? that space is very critical problem today's නේද? දැන් අද space එක කියන එක හරියයි හැමෝම බලන්න tiny equipments වලට. ඒ හින්දා අනිත් එක තමයි costly. 3 input OR gates costly. Then the 2 input. ඒ හින්දා cost එක වැඩි වෙනවා. අනිත් එක මොකද වෙන්නේ? space එක we cannot utilize. හරිද? ඒ හින්දා ඇයි එකම දේනේ මේකෙන් කරන දේම තමයි අපි 3 input එකෙන් කරන්නේ. හරිද? So that means before using that one, before going to draw that one, we have to do the minimization. Minimize කරලා දෙන්න. But it is easy. And it is the more convenient one. හරිද? Is it okay? PAL. Next one is මේවා බලන්න. Okay? These things you can go through these stuff. ඊළඟ PLA ඉස්සෙල්ලා කරේ PAL නේද? හරි PLA programmable logic array. There what happened? Both sides are programming. හරිද? That AND gates and the OR gates both can be programmed. දෙපැත්තම අපිට ප්‍රෝග්‍රෑම් කරන්න පුළුවන්. එතකොට මේකෙත් අර විදියටමයි ඔයගලන්ට හිතන්න තියෙන්නේ. හරිද? Here you can see A equals this one, B equals that one. Okay, එතකොට මේක බලන්න මිනිමයිස් කරන්න පුළුවන්ද තව කියලා. හරිද? මිනිමයිස් කරන්න බැරි නම් according to that one what happened? A and B, two outputs are there. That means two OR gates. How many inputs? X and Y, X, Y, Z. Neither. 3 inputs are there. That means 3 input buffers. How many min terms? X, Y, X, Z dash, X, Y dash, Y, Z, X, Z dash. Both are repetition. And 4 min terms are there. That means 4 AND gates are there. So those are input buffers. And these are 4 AND gates. These are the 2 OR gates. එතකොට මේ පැත්තත් අපිට ප්‍රෝග්‍රෑම් කරන්න පුළුවන්. This side also we can program. එතකොට A කියලා කියන්නේ xy plus xz dash. හරිද? එතකොට මේකෙන් අපි හදා ගන්නවා xy. Okay, this one xz dash. This one xy dash. This one yz. හරිද? ඊට පස්සේ මෙතෙන්ට අදාළ විදිහට අපි ස්විච් කරනවා. A equals xy plus xz dash. මේකෙන් එන එක මම මෙතන ලියලා තියෙනවා. Here what happen? xy dash මෙයා switch වෙන්න ඕන, yz switch වෙන්න ඕන, xz dash switch වෙන්න ඕන. So that is the thing. හරිද? That is that PLA, programmable logic array. Both sides can be programmed. හරිද? එතකොට මේකේ තව අපිට මේ මෙතෙන්දී අපි we are not doing the simplification. Okay, we take as it is. But when we are doing the simplification, හරිද, simplify කරද්දී චුට්ටක් ඔයගොල්ලන් බලන්න ඕනේ F1 එකත් simplify කරන්න. Okay, here F1 is given like that, F2 is like this. එතකොට F1 simplify කරන්න drawing the Carnot map. F1 dash and F2 dash also you have to do the simplification. හරිද? F1 dash and F2 dash. මෙයාගේ inverter එකත් simplify කරන්න. එතකොට for this type of thing, 2 inputs are there. That means you have to draw 4 Carnot maps. F1 වලට මේක F1 dash කිව්වොත් මේ 1 ඒවා 0 කළා, මේ 1 zeros තියෙනව 1 කරන්න. කරලා ඒකත් simplify කරන්න බලන්න. හරිද? ඊට පස්සේ ඒ දෙකම බලලා බලන්න ඔයා select කරගන්න ඕන තියෙන ගොඩක්. ඒ කියන්නේ that duplicating terms. Duplicating terms are the very important one. හරිද? duplicate වෙන terms තියෙනවා නම් අන්න ඒව තමයි අපි consider කරන්න ඕනේ. හරිද? මේක බලන්න one element. 1 එක consider කරලා F1 හදලා තියෙනවා මෙහෙම. හරිද? 0th element consider කරලා F1 මේ විදියට හදලා මේකේ dash එක. හරිද? F1 equals this one dash. එතකොට F1 dash කියලා කියන්නේ ඇතුළේ ටික. හරිද? here F2 one මේ ones complete මේ consider කරලා F2 මෙහෙම හදලා ඊළඟට F2 ආයි 0th element consider කරලා හදලා තියෙනවා. එහෙනම් මෙතන dash එක දාලා F2. හරිද? එතකොට දැන් මේ හතරම බලන්න. මෙයාත් එක්ක මෙයා බලන්න, මේ F1 ones element එකත් බලන්න, F1 F2 0th element එකත් බලන්න. එතකොට වැඩියෙන් duplicate තියෙන ඒවා තමයි ගන්න ඕනේ. හරිද? මේක අපි මේ දෙන්න ගත්තොත් මේකේ මොකද වෙන්නේ? A dash B dash A dash C dash B dash C dash. මෙතන duplication නැහැනේ මොකක්වත් නේද? එතකොට අපිට මෙයාගේ ගත්තොත් කොච්චර min terms අඳින්න ඕනද? 1 2 3 5 4 5 6 6 min terms need to be considered. That means 6 AND gates need to be there. හරිද? මම උනට මේ F1 එක මේ F2 ගත්තොත් මොකද වෙන්නේ? Here what happened? A dash B dash නෑ. A dash C dash ඒකත් නෑ නේ. B dash ඒකත් වැඩක් නෑ. එහෙනම් එයාගෙත් 6 ඇඳේ. හරිද? ඊට පස්සේ මම මෙයාත් එක්ක මේ F1 dash එක ගන්නවා මෙයා F. එතකොට A B AC නේ. A B AC. මෙතන BC. මෙතන මේක. හරිද? එතකොට මේ දෙන්න ගත්තොත් මොකද වෙන්නේ? මෙතන 1 2 3 4. Only 4 min terms are there. හරිද? එතකොට 4 AND gates විතරයි අඳින්න ඕනේ. නේද? මෙයයි ගත්තොත් there is no any duplication. හරිද? එතකොට duplicate ඒවා තියෙන එක consider කරන්න ඕනේ. ඒ හින්දා හැමතිස්සෙම මොකද අපි කරන්න ඕනේ? F1 අඳින්න ones element එක consider කරලා 0th element එක consider කරලා F1 අඳින්න. හරිද? එතකොට මේ F1 මේ දෙන්නත් එකම consider කරලා බලන්න. මොනවත් එකද වැඩිපුර අපිට duplicate terms තියෙනව ගන්න පුළුවන්. Duplicate terms වැඩි කියන්නේ අපේ මොකද වෙන්නේ? AND gates ගන්න අඩු වෙනවා. It is the more efficient one. හරිද? So here you can see each other combinations give 6 AND gates. But in this combination, F1, this zeroth element, it can F1 dash. F1 dash and F2. මේ දෙන්න ගත්තොත් අපිට කොච්චර දෙන්නේ? 4 AND gates need to be there. හරිද? ඒතර 4 AND gates තියෙනවා. ඒතර ඒ වගේ වෙලාවට you have to මෙන්න මේක අඳින්න ඕන. PLA program table එක අඳින්න. It is easy. නේ? අපිට ඕනේ min terms 4යි. Only 4 min terms. හරිද? 1 2 3 4 3 inputs A B වශයෙන් inputs ටික ලියා ගන්න. Outputs මේ තියෙන F1 F2. හරිද? True form එක නම් true ලියන්න. Complement form එක නම් complement ලියන්න. Is it okay? හරිද? එතකොට මෙතන මම ගත්තේ කොහොමද? මෙයානේ ගත්තේ නේද? F1 equals AB plus AC plus BC dash. මේ තියෙන AB plus AC plus BC dash. F2 වල මේ form එක ගත්තේ. හරිද? එතකොට මේ time එක මේක fill කරන්න ඕනේ. You have to draw this one. PLA programming table you have to draw. You should draw. හරිද? එතකොට what are the min terms? AB, AC, BC and A dash, B dash, C dash. හරිද? එතකොට පළවෙනි එක F1 එකේ AB එනවා. හරිද? AB A එක plus B plus. හරිද? එතකොට F1 එක මෙයාගේ මොකක්ද එන්නේ? True එකද complement form එකද? F1 තියෙන complement form එක. මේ F1 වලට එන්න ඕනේ මෙයාගේ value එකේ complement එක. That means you have to put under F1 as the complement. හරිද? Complement එකේ F1 තමයි අපි ගන්න ඕනේ. F1 නෙමෙයි F1 complement should be there. F2 නම් true form එක අපි ගන්න ඕනේ. හරිද? So to see here 6 terms are there. Here 1 2 3 6 terms we can prepare there. Its complement one we should use. F2 how many terms? 3 terms are there. There are the 3 terms. There we have to take the true form. So this is the PLA programming table. By looking at that table, we can draw the logic diagram. PLA implementation we can draw. Here you can see 4 AND gates are there. Each and every points we can program. Okay. 3 input buffers are there. So that means according to that one A dash likewise. එතකොට මෙතනින් අපි එනවා මොකද්ද මේ දෙක click මේ trim කරොත් trigger කරොත් A and B. AB comes here. From this line what happened? A and C we can take. From this line B and C. From this line A dash, B dash, C dash we are getting. 4 min terms we can taken from there. After that, according to the input F1 and F2, so here F1 we need to, there what happened? F1 is complement form. So how we can take the complement? There you can use NOT gate also. නේද? මේ එක not එකට feed කරත් F1 එක ලැබෙන්නේ. That before that not using this one is some programmable thing. හරිද? Here XOR gates are using. So there what happens? 0 and 1. 0 and 1 feed according to that one. We need F1. That means we are triggering that part and here 1. That means already we get that F1 dash there. Here what happened? F2 need to be there. So that one we are triggered there with the zeros 1. So that means F2 comes here. That programming stuff also, it's easy when we are using. Okay, only we need doing the programming thing. එහෙම නැත්නම් F2 you can take it directly there and here you can feed the NOT gate to take the F1. Okay, so that option also there, but this one is most systematic one. Okay, so that is the PLA implementation. I discussed several questions. Maybe questions කීපයක් වගේ අපි discuss කරා. Okay, please go through these questions. Right. So this is all about the micro 3. ඔය ටික තමයි අපි micro 3 වලට කරේ. හරිද? හරිද? එතකොට තියෙන lecture notes ටික බලා ගන්න. You have to do more 3 or 4 past papers. It is enough. At that time you can A plus you can gain easily. Okay, any questions? PLA ඔය ටික බලා ගන්න. I already lecture note එකක් ඇති ළමයි ළඟ. lectures ආපු අය ළඟ. මොකද මම board එකේ ඉඳලාම පැහැදිලි කරා ඒක. It is important for you as the electrical and electronic students. Any questions? Madam? ඔව්
මැඩම් discrete component කියන්නේ මොකද?
discrete මොකද තියෙන discrete components? Discrete component means normally that 1, 0, those are normally we are calling the discrete component. It is not the time continuous one. Time එකත් එක continuously change වෙන එකක් නෙමෙයි. හරිද? It is like a digital, not a digital. Digital also some continuous signal. Discrete signal කියලා කියන්නේ එක time එකකදී විතරයි present වෙන්නේ. At t equals 1, t equals 2, t equals 3. එහෙම. Then clock signal is a continuous one. It is not the discrete one. හරිද? t සමාන 1 දී විතරක් value එක තියෙනවා නම් අන්න ඒක discrete එකක්. t සමාන 3 දී විතරක් value එක තියෙනවා නම් discrete. ඒතර ඒ වගේ වෙලාවක 2යි 3යි අතර values present වෙන්නේ නැහැ. It is not the continuous one. හරිද?
ඒක මැඩම් 2017 මේ PLD question එක ඇවිල්ලා තියෙනවා. කියන්නේ function එක දීලා ඒක diagrams අඳින්න කියලා තියෙන්නේ.
Normally 1, 0 means the discrete one. 1, 0 normally when we are drawing the 1, 0, those are discrete one. අපි දැන් diagrams අඳින්නේ normally discrete ඒවට තමයි, not the continuous one. හරිද? අපි continuous වලට අඳින්නේ නැහැ, clock cycles ඒවට අඳින්නේ නැහැ. 1, 0, 1, 0 වා කියන discrete values. ඔයගොල්ලන්ගේ කියන papers I haven't those papers. හරිද?
මොකද්ද වැඩ මේකට අඳින්නේ? ඒ කියන්නේ මට ඒක තේරෙන්නේ නැහැ. අර PROM එක දීලා තියෙන discrete component එකට අඳින්නයි PROM එකට අඳින්නයි PLA එකට අඳින්නයි කියන්නේ. function එක f equals කියලා දීලා function එක දීලා discrete component එකටයි PROM එකටයි PLA එකටයි අඳින්න.
ඔව් discrete component එකට කියලා තියෙනවද මොකක්ද ඒ කියන්නේ? Discrete component. Normally we are drawing for the discrete component. 1, 0 කියලා කියන්නේ discrete. Continuous නෙමෙයි.
Question එක මඩම් දෙලා තියෙන draw the related circuit diagrams if following methods are used to represent it.
Discrete components කියන්නේ here I think that discrete component means normal logic gate. ඇහුණාද? හරිද? normal logic gate එකක් අපිට අඳින්න පුළුවන් නේ normal combinational logic circuit එකක්, that is the discrete one.
හරි මැඩම්.
normal දැන් ඔයාලට function එකක් දීලා තියෙනව නේද? මොකක් හරි function එකක්. What is the given function? එක function එකයි නේද දීලා තියෙන්නේ?
Oh, f equals
Hari. Okay. That discrete component means normal logic gates. Through the normal logic gates, you can express that function. F equals think that ABC plus A dash C dash. මොකක් හරි එකක් ඔයගොල්ලෝ combinational logic circuit එකෙන් අඳින්න පුළුවන් නේද? තේරෙනවද මම කියන එක?
ඔව් මැඩම් හරි.
අන්න ඒක තමයි discrete components කියන්නේ. හරිද? It is easy. ඔයගොල්ලන්ට මේ වචනේ තමයි ප්‍රශ්නේ. combinational logic circuit එකෙන් අඳින්න that is the discrete component. ඊට පස්සේ PROM එකයි තා මොකද දීලා තියෙන්නේ? PAL එකද? හරි ඒ දෙක අඳින්න පුළුවන් කොහොමද?
ඔව්.
නේද? ඒ දෙක අඳින්න පුළුවන්. discrete component means normal combinational logic circuit. Is it okay? හරිද? හරි. Any other questions? හරි. දැන් ඇති නේද? more than 2 hours නේද? 3 hours වලටත් කිට්ටු වෙනවා. හරි එහෙනම්. තව තියෙනවද මොන හරි? හරි. මං හිතන්නේ දැන් ගොඩ දුරට මම cover කරා. හරිද? මුළු මේ presentation ටිකම ආයි මම revise කරා. හරි. එහෙනම් I'll stop. I'll winding up the session. Okay. Do the exam paper. Okay. Best of luck for you. I think 24th නේද exam එක. එහෙනම් හොඳට කරන්න. institute දෙකේම අයට කියන්නේ. Okay. හරි.
Thank you madam.
Okay.
Okay. Thank you madam.
හරි. හොඳට exam කරන්න. ඒක තමයි අපිට කරන අපි කියපු දේ හරියට තේරුණා නම් you can do the exam well නේද? හැමෝම ඒ ගන්න A+ ගන්න කරන්න. හරිද? හරි මම මේ assignments ටික මේ mark submit කරනකොට රෙප්ලාට mention කරන්න. හරිද? එතකොට ඔයගොල්ලන්ට කොහොමත් මේ කොළඹ අයට මම දාන්නේ assignments දෙකක marks විතරයි. Okay? That finalized mark I think from madam that මොනවා sir දායි. I only send that 2 assignment marks only. හරිද? හරි එහෙනම් අපි wind up කරමු නේද? හරි. Thank best of all. Okay? Best of all for the exam.
Thank you very much madam.
Thank you.
Thank you, madam.
Thank you.